Before we open Godot, here's the plan. Over this series, we're going to be building a full Souls-like action RPG from scratch, with movement, combat, enemy AI, inventories, everything you can think of. But we're not going to be cramming everything into one giant script. Each system is going to be built on a standalone, and then merged near the end, or as we go along, depending on the system that we build. That's generally how real games are made. Part 1 is going to be the foundation of our entire game, the player. We'll also build the state machine with the player, so let's get into it. All right, so once you've downloaded the latest Godot 4 version 4 executable, whether it's Godot 4.6 or Godot 4.7, anything that is after Godot 4, we will now launch it. Also keep in mind here that I also have the K-Kit packs that we're going to need for this next part, which is going to be for the player. Next, we will go and create our project. Make sure that you set the path to wherever you want your project to be, and we will rename the project to something like 3D Souls-like game. And I'm going to add a YouTube tutorial right after. Now, of course, you might not want to add that because this is my YouTube tutorial. And next, we will look at the renderer. There are 3 renderers here. And the one that we're going to want is a Forward Plus. This is used for advanced 3D graphics or just 3D in general. We'll make sure that Edit Now is checked off, and you can pick Git or None, but Git is going to help us push this to Git in the future. So I usually leave this selected. We'll hit Create. Once you've created your project, if we go back to our desktop, you will see, or wherever you saved it, you will see your folder has now been created. Now in here, I'm going to simply drag the folders and pop them into the new folder that we just created. If we open up Godot, you'll see that the assets are going to be imported. After a few seconds, we'll now see the new folders that we just created. Now to keep things organized, I'm going to create a new folder called Assets. I'm going to drag both these folders into the Assets folder and click OK. Once that's done, we can now create 2 new folders, one for scenes and one for scripts. This is just to help us stay organized in the future and make sure that we have somewhere to put everything. All right, our next step is to actually go to project settings and start setting up our input mapping. Here we'll find input map and we'll be able to add anything that we want. First, we'll create move left, move right, move forward, and I'm going to go ahead and add all the inputs that we need to add, and I'm going to speed things up a little bit. Next, what we want to do is configure these with an actual input, because right now the actions do exist and we can refer to them in code, but they won't be able to actually trigger or get triggered because we don't have anything to trigger it. So to do that, we'll add the add event from the plus button on the right-hand side, and you can see here that it's listening for event, which means if I click on my keyboard, so in this case, move left should be A, I can click OK. We can also go back and click the left on my keyboard, and that will do the same thing. Now, you could also, another option, which is actually important for the mouse toggle, is to go in here and find what we want. So here, we're going to go to either mouse buttons. Sorry, that's the wrong one, actually. We're going to go to attack. Attack is the one that we want, where it's mouse button, left mouse, and we click OK. All right. So the left mouse button, if it gets clicked, we will attack. The toggle is actually escape. And I'm going to go ahead and fill everything out. And you can kind of do whatever you want though. All right, I filled everything out. This is just kind of what I like to have for my input mapping. It's what feels the most natural to me when I play these kind of games. So hopefully you've also filled it out with whatever you'd like, whether it's the left physical key or A key, whatever it is. For attack, same thing. You honestly don't even have to use the left mouse button, but this is what makes me most comfortable. All right, next, what we want to do is actually set up our first scene. Here we have, on the left-hand side, create root node. We can create a 3D scene. We'll create a world, hit save, and save this into our scenes. Now, you'll notice that we don't have anything. Now, what we're going to do first is create a floor. So to do that, we're going to create or add a static body 3D with a mesh instance. And normally we would add a collision because if we notice or read this, it's telling us we need a collision 3D. But I'm going to show you guys a cool hack to make this a little easier for us. I'm going to add a box mesh. I'm going to go into the mesh and go to the size, and you can set the Y, the Z, and the X. Here, I'm going to set 15 by 15 probably. That's probably enough. We'll now go up to the mesh on the top, create collision shape. We'll do sibling, and then we can do single or simplified convex. They should make the same thing, which will just end up being basically the shape that we have. And this is now our ground, and you'll see our error went away. Now, an alternative method, if you guys wanted, if we had only the mesh instance, we could have also created a static body child. Same thing. And that would pretty much do the same thing. If I hide this static body, you'll notice that it's essentially the same. So I'm going to go ahead and delete the old one. But again, the ordering here doesn't actually matter. So I'm going to rename this to floor and just hide the rest. Next up is we want to create our player. Now we have two options to create our player. One would be either to add it through our world scene and add it like this, or we can create either a new scene, an instance scene over here, or we can also create a scene over here. Now, this is not usually my preferred way of doing it, so I'm going to go ahead and cancel, but do know this is a way, and you can go node and select whatever you'd like. So instead, I'm going to go ahead and create a new scene called Character Body 3D by adding the plus button again and clicking other node just in case you missed that. And I'm going to rename this to player. I'm going to hit Control S or Command S if you're on a different OS. I'm going to create a new folder called player and save my scene in there. Now I'm going to do the same thing by adding a mesh instance, but this time we're going to add a capsule mesh, pop it up a little bit. And if you noticed, my guy kind of snapped up there a little bit, and that is usually because the snapping is on, but it's not, which is a little weird, but that's okay. We'll just create a collision mesh here with a sibling this time because the character body is already the body that we want. We just need the collision shape. You'll notice that it's kind of inside, but it is the right shape that we need, or somewhat right shape actually, because we did simplified, but we're actually going to do single convex here. All right, now let's hit Control S, go to world, and you'll notice that our player isn't here. That's because we didn't add him yet. So if we find our player scene on the left-hand side, I can simply drag him down by dropping him wherever I want. Or if I drop him into the world scene on the top left, he'll simply enter at the origin point, which is 0, 0, 0. I can move him up a little bit and let's hit play and see what we can get. If I select current while I'm in the world, that should work, but we can also just do select and select the world. Now, a quick note. Well, first of all, we see nothing, which is not unexpected, but it is a problem. One note though, if you did select the wrong scene when you hit play, if you right click something like a scene, you can actually now say set as main scene. Now, we're not going to do that for the player because that wouldn't really make a lot of sense. Now, to make this work, to actually see our player, we now need to add a camera 3D. I'm going to add my camera and just move it up a little bit and now face it down on the right-hand side. You can see the preview. And now when I hit play, we'll see the player. Now, the scene doesn't look the same, and that's okay. We'll address that in just a minute. But before we do that, we want to add our player script. Let's go over here to the add the player script, but this time I'm going to add it in the scripts folder. And again, give it its own script folder player. And make sure that when we did this, actually, you select the template, which I did not do. So let's do that. Go to the script, and you'll notice that we now have a script. And this was our old script. So if I close that, it'll be overridden. Oh, doesn't look like it was. So let's actually close this and make sure we paste this into the actual player script that is in our player. There we go. So this is our player script for the template. Now this is going to allow us to move. Now, I can move left and right, up, down, wherever. You can see my player is moving. He can even jump up and down. Now you'll notice though that this doesn't work with our input mapping yet, and that is because it's using UI left instead of move left. And if you do that, that will replace all of these with the input mappings we just added, then it will work with whatever you did. But don't worry about that too much just yet because we're going to be removing a lot of this soon. Now, before we move on, and before we actually get into the next step, we now need to understand what a state machine is. So let's take a look at what that is. A state machine is just a system that says your player is always in one state at a time. Idle is one state and move is another state. And a transition is just a rule that decides when to switch. So instead of one giant script full of if statements, each state owns its own behavior. To make this work, we need a brain. The brain does two jobs. It runs the current state every frame, and it switches states when we tell it to. Now let's code that brain. Here's our state machine script. It stores the current state. It has a function called change state, and every physics frame, it calls a physics update on the current state. That's literally the core. Now in Godot, add a child under your player called state machine, attach this script. Nothing will happen yet because we don't have any states. So next, we need to define what a state will look like. Every state should follow the same contract. When we enter a state, we might reset the variables. While we're in a state, we run the state logic. When we exit, we might want to clean some things up. So every state will get enter, exit, and physics update. This is base state. It doesn't do anything by itself. It just defines the functions that every state will have. Create basestate.gd in your project. Now we can create our first real state, idle. Idle state is simple. While we're idle, we check for movement input, and if input exists, we transition to move. Here's the code. Read input. If the input magnitude is greater than 0, tell the state machine to switch to move. In Godot, create idle state, and attach the script. And we pass the references it needs, the player, and the state machine. Now let's look at the move state. Move state does two things. One, it applies movement while there's input. And two, if input stops, well, we want to go back to idle. This is move state. If there's no input, switch back to idle. If there is input, call the player's movement function. Now, this is an important rule. The player owns the movement math. The state decides when it's allowed. Now hit play, and you should see the state switching live. Idle, move, idle. And that's a working state machine foundation. Now you understand what a state machine is, and you have a working brain in Godot 4.6. This is the exact foundation that you build a Souls-like controller on. And that's it. You now have a working state machine in Godot 4.6, a brain that tracks states, a contract that every state follows, the two real states wired up, and switching live. This is the exact foundation you build a Souls-like controller on. But obviously, a Souls-like character has way more than just idle and move. You've got rolling, attack, hit reactions, maybe die states. And each of those states has a lot more logic than what we covered. Animation handling, timers, combo windows, stamina checks, and more complicated math that makes things feel smoother. There's also things like input controllers. Instead of repeating input.getVector and input is action pressed, in every single state, you create one input controller that reads all the inputs, and every state just reads from that. Cleaner code, easier to debug, and it makes things like input buffering way simpler. All right, now back in Godot, we want to start creating our state and state machine in Godot as a script. So to do this, I'm going to create a new script inside of my player folder, and I'll just call this state. Now, to start, we need to actually define this as its own class name by doing class name state. And if I hit save, we now have this as a class. Now, what does that mean? Now, I'm going to go over here into extends character body, and I don't want you to do anything. I just want to show you that I should now be able to extend state. Now, obviously we'll get a bunch of errors and that makes sense, but I do just want you to understand that now we have our own class name. That means we can now extend from this script. So what do we want as a base thing inside of this script? Well, first of all, we would probably want our state machine to be accessible from here. And we can have this as a node for now. Next, we'll do our player. This is kind of it's referencing the actual player, right? Because sometimes we might want to actually adjust the player's speed, whatever. And we'll do that by setting it to character body 3D. And that's it. Next, we want our functions. One function that we'll have is enter. And this is going to just pass for now. Now, the enter function will actually have it return void as well, just so we can define that and make sure that it doesn't return anything else. I'm just going to duplicate this a couple times. When I say couple, I mean 3, and I'm going to change the names. So enter, I'm going to say exit. Over here, we're going to update. So what this is just literally an update value, which is going to happen every delta. This is also going to be returning void. The last one is physics update. All right, and that's it. We're basically creating these functions that will allow us to be used in every single state that we create. So idle state, walk state, etc. All right. So now we have the foundation of our state set up. The next thing we want to do is set up our state machine itself. And we'll do this again by creating our own new script here and call this state machine. I'm going to actually do an underscore machine like that. That way we have a state machine. Okay, now in here, we're going to do a very similar thing. We already extend node, but we're going to create a class name state machine. All right, now what do we need in here? Remember, this is the manager of all the states. So ideally, we have the initial state. So what we can do here is export variable initial state. And the cool part is we can define this as a state, the class that we just made, meaning any state that has this script that extends this, we can now put it into this variable. Anything else won't go into this. Okay. Now, here's 3 other variables that we're going to need. The current state, a dictionary of all the states that exist, and again, the player. It's going to be good to be able to access the player from the state machine as well. Now, from here, we need to have a ready function where we're going to do a few things. The first thing we're going to do is we're going to await process frame. Now, this is kind of an odd or awkward moment or awkward line of code, but the reason we add this, a lot of the time, the idea is we're doing something inside of this state, or this function, like the ready function, that is happening, or we want it to happen one frame basically right after the other states happen. So sometimes if we have our state or idle state doing something in the process frames, it can kind of cause errors in the ready function here because it's not set up yet. So that's kind of the idea. Now, if you don't get it, it's totally fine. The idea here is basically we're kind of pausing this function for a quick second before actually going through with the rest. All right, the next part is to actually access our player. Now, there's a lot of ways we can do this. We can, of course, export it as well, but here we can just say player is equal to get parent as character body 3D. Now, what does this mean? This means that our state machine has to now be a child of the player directly. So if I add state machine as a node, it'll actually show up, and we can do that. We can hit create, and there it is. Now, there is a short distinction I want to just throw out, which is if I create a node and I set the state machine script to that node and I renamed it to state machine, that's basically the same thing. So if you see this script that's grayed out, that means it's a custom script. I mean, it says it's a custom script that's built in, and we can't really change it. It's just meant for that as well, specifically. But it's basically the same thing. Okay, so here, back in our script, we also now want to check to see if player is valid or not. This is basically just a safety precaution. And if not player, we're going to push error and say state machine must be a child of character body. And that is because I have a space right there. That's why I have that error. All right, but that's it. Next, we want to actually get all our children for the states. We want to allocate all the states that we have in our states dictionary. So to do that, we'll create a for loop child in get children. Now the children are going to be the states. Now at the moment we have 0, so this will actually not do anything, but we're going to set it up so that once we start adding children, it'll work properly. If the child is a state, meaning it's an actual state that we want, like an idle state or whatever, then what we'll do as a cautionary tale, we're going to make sure that it's lowercase. We're going to take everything to lowercase and make sure that we're checking this way, because sometimes I will make a mistake of adding a node and I'll be like idle state, something like that, where there's a bunch of capital cases and things are not consistent. This will basically just defer that and make sure that the code is basically overriding my faults. So next, we'll set the state's key to equal to child. We're going to see if the key ends with state. If it does, we're going to replace the key with the child. Lastly, we're going to actually set the state child or the state machine and the player in here. So now that we're adding the states into our state machines, we're going to make sure that each of these states now know what a player and a state machine is. So the state machine is just self because this is its own script, and then player we can equal the player because we have the player over here. It's the same name, so it can be a little confusing, but this child.player is referring to this child.player. All right, once we've done that, we now want to set the initial state because this is still in the ready function. So we need to do something with the initial state. We'll do that by asking if the initial state is valid, like if it exists, then we'll enter that state. We'll do that by saying .enter, and we'll also say current state is equal to initial state. Now, if the states.size is bigger than 0, we'll also want to set the current state equal to the state's value at 0. This is basically like if initial state is not valid, right? So if we don't set an initial state, it'll set it to the first state that exists that we created, which obviously we can make it anything we want, but ideally we set it to idle. All right, the next part is to actually make these work, the update and the physics update. And we will do that inside the state machine. And we can do that very easily by saying function process delta float. This is a built-in function. In fact, if you actually type it in, you will see that it tries to complete it for you. And this physics process is a different one that we're also going to do in a second. But this current state is going to be updating using the delta with that exact value. So you can see that we're passing through delta to be this delta, right? So now we have this process working for the update. Now for the physics process, we're going to do the exact same thing. In fact, I want you to pause the video and give it a try yourself. We basically want in the state, this function to start working. And we do that by saying if current state, same thing, and current state.physics update delta. All right. Now the last thing that we need at the moment is going to be a way to transition state to state, right? If you recall, a state machine is a way of transitioning from state to state. So we'll do that by first creating the function transition2. Now you can name this whatever you want, but I'm going to name it transition2. And this is basically going to pass through the name of the state that we're trying to go to. So it's a string. Now, first, we need to find that state. Now, again, I'm going to do this where I basically take the new state, create a new state, and it's going to take the state name that we took and take it to lowercase capital. So if I typed in, for example, to transition to, and I typed in idle state like that, you can see that the T here is capital. It'll basically take it to be idle state like so. This way, it's comparing lowercase stuff to other lowercase stuff. This way, we're not being inconsistent with our code. The next thing is to make sure that this state actually exists. And if it doesn't, we'll return. So if the new state doesn't exist, or if it's already equal to the current state, then we're just going to return. We're not going to transition anything. That's it. Now, if it does exist, that's where we do stuff. So the first thing we do is we want to exit out of our current state. Now, this is actually important. The order that we do this, if you think about it, we want to exit the state that we're in first, and then enter the new state. Now, we'll do that by saying current state.exit, because that current state as the exit function that we created just a minute ago. After that, that's when we can enter the new state. Now, I want you to pause the video and give it a try yourself. Think about, hey, how can we enter the new state? Well, first of all, we haven't created or added the current state. We haven't updated the current state. So first, we need to set the current state equal to new state, and then we will say current state.enter, okay? And that's it. This is the transition to function that will work for us. Now that we have the foundation set up, let's take a look. Okay, the foundation's done. We've got the project, a player, and a working state machine. Now for the part that actually makes us feel alive, animations. We're going to bring in a character, setting up an animation tree, and wiring up all the idle, walk, and run animations. This is where this actually starts to look like a game. Okay, what's next? All right, now that we have our player and the foundation set up, we now want to add animations. Before we do that, we will want to add the actual characters and rigs. So let's head over to the Adventures tab and find a character that we want. Inside of Characters, GLTF. Here you can explore the Mage, the Ranger, whichever one you want, and add them into the game. I will add the Barbarian to stay consistent with my solution. Here, I'm going to delete the mesh instance, and actually I'll leave the collision, but I'll delete the mesh instance. And inside of my collision shape, we'll just reset this and select a capsule shape and make it fit the player as much as possible. Now, we do want the collision to go a little under the head, just because we don't want the head of the top of the player to collide sometimes. All right, from here, we will simply make local, and we now have a skeleton with a bunch of bones. Here, we want to set up the animation. To do that, we will need to go to the animations, GLTF, rig medium, and set these up. Now, to do this, you will not have these movement advanced, or maybe you do if you already downloaded the pack on my website. But if you don't and you want to figure out how to add those, it's super easy. All we need to do is pick one of the GLB files, and in here we will have all these animations, and simply go to Actions, Set Animation Path, and you would save this wherever you want. So here you can see that I have General over here, and if you select Current Folder, you can do that, and here you'll see it already saved, so I can't save it again. And you would set paths though, and that would be it. So you do that, re-import, and you would get all of these. So you would get the .res files. You may not have the .tres file, but I'll show you how to set that up in just a minute. First, we need to add an animation player. We'll also add an animation tree just to get ahead of ourselves here, but we'll focus on the animation player first. Here, we will go to Manage Animation, and what we'll do is either click New Library or Load Library. I will load a library to show you if you already downloaded this set from me. We can find one of the rigs, go to General, and the .tres file is a library, so we will take that. And in here, we will see all these animations. Now, you might be wondering though, how do I make my own library? Well, it's actually really easy. We can simply say, make a new library, give it a name. We'll go to the load right here, the load animation, and you can select all these files, or obviously you would want the attack files, so we can do that by selecting all of these, and we don't need the .tpose, so we'll just do that. Hit open, and it might take a minute. What the dude? All right, once you've added all the animations and they've all loaded, we simply have to go to the save right next to the actual library, and this will allow us to save as and save this as the attack underscore lib or lib library, whatever you want to call it, and we can hit save. Now, once you've done that, you will now see attack underscore lib.res, but you will also see the library icon right next to it, and that is the library that we just created. So anytime in the future, if you want to go to manage animations and add a new all these attacks animations into a different player or character, then you're able to do that much faster. Okay, now that we've done that, we now want to set up our animation tree. But before we do that, we'll have to resolve this little error here so we can actually test our animations and make sure they're working properly. We'll notice that the animation is looking for rig medium / skeleton, and that means that it needs to be a child of the barbarian. So we actually need to move the animation player into the barbarian. And now if I reselect something, now if it doesn't automatically reconfigure itself and it doesn't automatically work, and you see your player still doing the T-pose, over here in the root node, simply click the loop button here and reset it to the barbarian. And now it should work properly. Now from here, we should actually be able to move this and it should still be connected to our player. And there we go. We'll now be able to test all of these animations and see that they are connected to our player. And there we go. Now let's head over to our animation tree and see what we want for this. So for the animation tree, we need to use a tree root. For the tree root, we will be using the animation node state machine. We'll assign the animation player, and in here, we'll now right click, we'll add animation just to show you, but the cool part here is that we won't actually be using the animation directly. We'll be using something else. We will be using a blend tree. From here, we'll rename this to idle, and inside of the blend tree, we'll go add an animation, and now we can select the animation we want. But to make this a little easier, we will bring this up a little bit, go back in here and select the idle animation that we want. Going back into the tree, we now want to add several different animations. We will add idle, walk, run, dodge, and then we'll do jump start, jump loop, and land. So I'm going to go ahead and do that and speed things up a little bit. And once you've added all the nodes, we do need to set up the walk and run. And I mistakenly forgotten to add that library from the movement basics. So let's go ahead and do that in the manage animations and create a new library called movement. Now I want you to go ahead and give this a try yourself and add all the animations before moving on. All right, once we've done that, I will go ahead and save the library here as movement _lib and hit OK. And save. Going back to the animation tree, we can now go into the walk and select the walk animation. We'll go to the same thing, run, and go ahead and complete the rest. Now, one thing to note is in the jump start and the jump loop and etc., we want to, select the jump start in here. In the jump loop, the reason why we're doing this way is because the jump idle is essentially we're in the air. So if I go to the animation player and I play the jump idle, you'll notice that this is him in the air. And so we want to play this when I'm not touching the ground and then play the jump land when I touch the ground after the end of my jump. And that would be the land. So in here, we would select the jump land. And that's it. In the dodge, we can simply select something that works as a dodge. I don't believe this pack has a dodge, so we will have to use something similar, which will be using dodge forward. So let's go ahead and add that to the movement. So inside of the advanced movement, we'll find dodge forward and go ahead and open that. And we'll use that as the dodge in our animation. Now, once we've done that, we now want to connect everything using the connect nodes. Here we'll connect the start to idle, and this one doesn't really matter, but the rest of them will, because in idle to walk, you'll notice that this little idle has a green play button. And that means it's on auto mode, meaning that will automatically go from idle to walk. And you might be wondering, what do you mean automatically? It'll just ignore idle and go straight to walk? Yes, exactly that is what is going to happen. It will essentially ignore the animation of idle and go straight to walk. Now you can imagine if I had connected multiple, in fact, if I do that, then it will automatically start to bug out. So let's go ahead and see if we can get it to do that by playing walk. There we go. You'll now see that he's playing all these animations through one frame. Now, obviously we don't want that to happen. So let's turn off the auto in each of these nodes. And the reason we're doing this is because we're going to add conditions inside of code that will allow us to move between these animations by ourselves. So from here, we'll simply add all these nodes and get rid of the auto. Actually, the jump start, we won't need that. Jump here, we won't need this. So we'll only need to go through one cycle once we start the jump, but we should be able to go from walk to jump, idle to dodge, walk to dodge, run to dodge, and walk back to idle. And that should be it. So the basic idea between these transitions is you need to think about, hey, which animations do I want my player to smoothly transition between, right? Because if there's not a direct node between one animation and another, the animation will actually look a bit clunky, which in some instances you can use to your advantage and make it look like that if you'd like. But in most cases, if I want my idle animation to look smooth from idle to walk, we will want a connect node. Now, you might think we're done here, and we could be from idle to walk, but you'll notice that the transition between those two animations, it's quite abrupt, meaning it transitions very quickly. Now, the reason that is because one thing that's worth noting is that that 0.2 second crossfade that we set on every transition, it seems tiny, but it's a really big difference between a character that snaps stiffly between poses and one that feels like smooth and weighty. Souls-likes live or die on that weight, so don't skip the fade time. That small number is doing actually quite a bit. You will especially notice this once we get to the attacks and attack transitions. You'll see that if we don't add a transition like this, it's very snappy and doesn't look good at all. The X fade time is 0. So if we use this and put 0.2 instead, you'll notice that the transition is actually smooth. And now the annoying part, we will need to do this for every single node that we just added. So go ahead and do that. Now, there are some animations that we don't want to be super smooth. So in this case, from jump loop to land, I'll have this at 0.1. Or if you want, you could honestly just remove it completely, but it's totally up to you. Now, 3 more animations we will add before we move on is going to be hit small, hit big, and death. We'll add these just for now, just so we can work on them later, basically. Now, just one more reference to let you guys know. For the hit small, I am using the hit A, and the hit big is going to be the hit B, because to me, the hit A and hit B look slightly smaller. So hit A looks kind of small, while hit B looks a little bigger, meaning the damage we take is a bit bigger. Okay, now this is super exciting. Now from here, we can get coding. We're kind of done with all the slump work, and we can now actually code in some of these states. Before we can completely continue, let's create one more script, the input controller script. We'll work on this a little later in a couple of videos, but just know that this is an input controller that is going to allow us to manage all our inputs at some point. Let's just create it so we have it for reference later. Before we move on into the actual states, we first need to fix up our player script. Welcome to part 2. The player exists. He's animated, but now we want to make him actually move and feel good to control. Movement states, a third-person camera, and a centralized input system. Just a heads up, this part will have probably the most code in the entire series, so take it at your own pace, take as many breaks as you need, and make sure you're always stretching and standing up. So inside of our player script, let's first just delete everything other than the extended character body. From here, we're going to add 3 variables. Gravity, maximum stamina, and stamina regenerate. There are 3 other variables we'll add after that, but these ones are going to be our export variables. They kind of all do exactly what they sound like. This will be our gravity. This will be our maximum stamina for actually using stamina later. We will use this in the run state. The stamina regen will, again, regen our stamina. And after that, we need 3 more variables. We need the paused variable, stamina variable, an invincible variable. Paused is going to be Boolean, and so is invincible. Stamina is just going to be our current stamina. So you could honestly just rename this to current stamina, and that is it. Now, one more variable is the state machine. We need to be able to access the state machine from our player. So we'll simply say on ready var, state machine, node state machine. All right. And from there, we are good to go and start actually adding some functions. From here, we need a function that allows us to quickly get the gravity in a vector 3, because this is a float. And we could use this as a vector 3, but instead what we'll do is create a function that is get player gravity. And here it'll just say it's a vector 3. It's going to return vector 3. And we will again return a vector 3 with 0, 0, and gravity in the middle. So this will have y for our y axis, gravity. Now, whenever we need to access our gravity, this is a good, convenient way of doing so. One more thing we'll do is add a process function. Inside of that function, we will add, notice the pattern here. The idle state generates stamina, but only when we're not running. Little rules like this live inside the state, not scattered everywhere. And here's the golden rule for the whole series. The player owns the math. Like how you move, the state just decides when it's allowed. Keep that split in your head so that way the code stays clear and clean in the future. Add a condition that allows us to check if our current state is something that we want. Now, in this case, what we'll do is we can simply say if state machine and state machine get current state, this will basically check to see if our state machine actually exists and we can get the current state. If it does, then what we'll check is to see if the current state dot name is not equal to run. If it isn't equal to run, then what we'll do is add stamina. So this will immediately make use of our stamina regen that we just added. So now when we actually reduce stamina in one of the states, we will have a way of quickly regenning our stamina. Now, the awesome part about this is that when we're in the run state, it won't regen mana or stamina because of this condition. Because if we're in the run state, we won't be able to get stamina. All right. Now, the last part is just to make sure we kind of already have this. We have it right here, but we're going to add a ready function that sets our current stamina to the max stamina. Now, the reason we do this is because in the future, let's say we add save and load functions, and we want to change our max stamina, right? The player, like in the game, has now a max stamina of 200, let's say. You don't want to start your player scene where you have 100 out of 200. Well, no, you would want to start it at 200 out of 200. All right, that would be kind of weird to start at a weird valued max stamina. All right, now that is the player script. Let's close that. And now let's go ahead and create our idle state. There we go. Now we created our idle state script. We will now pop this up. And the first thing we need to do is make sure we define this state properly at the top. So the first thing we need to do is extend state and then create our own class name idle state. From there, we will add two variables that allow us to make use of this friction and floor snap. Inside of the ready variable or ready function, we will do two things. First, add an animation name or set our animation name to idle. And then we'll also say can move equal to true. Now inside of the state, we need to make sure to add these two variables. If you haven't done so yet, go ahead and do that. And then going back to the idle state, we will also need to add a couple other functions. We won't need the process function. We will simply only need function enter. Inside of here, we'll say super.enter. And then we will need the physics update. Now this physics update is again using the update we're using inside of the actual state. So keep that in mind. Now inside of this physics update, this is where we'll use or create the actual logic of our player going into idle state. The first thing we'll do is we will say if the player is not on the floor, let's add this gravity. Now we are getting an error here, and that is because the delta here is not the same. So we need to change this to delta. But yeah, so here we'll add gravity. If not, we will simply snap our player down to the floor. All right. From there, that's the gravity, but we need to actually deaccelerate our player. And we can do that by saying player.velocity.x and z will simply take the current velocity of the x and z and bring it to 0 over a delta of friction times delta. Now, this is pretty much it. But there is one more thing to actually make this work, which is player move and slide. Now this player will actually be able to move. Now let's go ahead and go back to our state and update this script a little bit. The first thing we want to add is a couple variables to be able to access things. So first off, we want to access the animation tree, and we can do that by saying variable animation tree. We haven't accessed anything yet, but we've created something to be able to access later. The other thing we'll need to do is using the animation player, and this is called an animation node state machine playback. We'll get into this a little later, but the idea here is that this will access inside of the animation tree and be able to play something for us. Now, the last thing we'll do is an input controller, and that is also for later. I know it sounds kind of odd to say like, oh, all this is later, but good planning is always part of good coding. So we are going to create an input controller. We already know this, so we'll be able to access it inside of our state. Now, one last thing inside of this script is to edit the enter function, which is to say, if animation name not equal empty and the animation player exists, then what we'll do is animation player dot travel to the animation name. Now this, let's go over this really slowly. This is basically checking if our animation name is valid and the animation player is accessed properly. Then we'll simply go into the animation player and travel. Now, what does this mean? Inside of our animation tree that we've already set up, basically, if I want to travel to walk, we will now go to walk. If I want to travel to idle, I will go to idle. Now, the cool part about this is that we have already created the idle state. We can add our idle state here, and you'll see the animation name here is empty, but obviously we already changed the script here. So inside of here, we have the animation name. Now, if you want, of course, you can just add idle over here. It will do the exact same thing. You don't even need any of this. You could just do this here, but I'm doing it in both just to show you how this works. And that's it. So now when we go into the idle state, it'll automatically play the idle animation for us. And you can imagine now creating other states like the walk state is going to be very similar in how we create this idle state. Let's go ahead and go to the next state. Now that we've created the idle state, we now want to actually test it. To do this though, what we want to do is go to the state machine and make sure that we select the initial state. Otherwise, we'll never actually initialize into any state. Now, let's just hit play and see what happens. Okay, so we've entered the idle state, but let's see what's actually happening in the remote section. If we go over to the state machine, we will notice that the dictionary actually has two states, and idle state and idle. Now, that's not really correct. The current state is the idle state, so that's correct. And you can see it right here. However, inside the state machine code, here we replace the node with the state. Now, this is why we have two states. So in order to fix this, all we need to do is change the name to idle. So from now on, whenever we add a state, we just need to name it whatever the class thing is. So if it's idle, we just say idle. If it's move, we just call it move. Okay. And we can hit play one more time, remote, go to state machine, and we now see that we only have the idle state, which is perfect. And that's it. All right, so next up is to create the walk state. To do this, we will simply duplicate the idle state and call it walk state. We'll go into the walk state script, and I'm going to replace the idle state with walk state, and I'm going to replace these variables with three others. We're going to create a walk speed, accel time, and rotation speed. We're going to make sure we export all three. These ones, we will just delete all these lines. We can keep these, except this one, we'll just turn into walk, and can move we'll leave as true. One other thing, we will put in the enter. Nope, that is it. This next bit might trip a lot of you guys up. So let me clarify. We're doing camera relative movement. Forward means forward relative to where the camera is, not a fixed world direction. That's why we grabbed the camera's basis and projected our input into it. If you've ever played a 3D game where pushing up sent you the wrong way, that's this, but done wrong. So we're going to do it right. So yeah, right. Now in the physics update, this is the question. How do we get our player to move? First off, we'll actually get some input direction. We can do this by saying input direction is equal to input.getVector, and then we will put the vectors that we want. Now, the way that this works is it's basically a 2 vector. So it's going to return 0, 0, or 0, 1, 1, 0, etc. Now, 1, 0 would mean that I'm going to the right, meaning that right is active. Now, what we would fill in these is like so. We would fill move left with move right, move backward, and move forward. So basically, if I press move right, this will be 0 and this will be 1. If I press move forward, this will be 1 and this will be 0, giving us 1, 1. If I press left, this will give me -1 and this won't activate, so it'll just be 0. And then move backward will be -1 as well. So that would be -1 like so. Now, do remember that this is a vector too, so we'll make use of this later. Okay, next up is to use our camera to actually move, because the way that a lot of Souls-like players move is by using the camera direction. Now, what we'll do is we'll get the current camera by simply saying player.getViewport.getCamera3D. This is awesome because this will allow us to just access whatever current camera is being used. Now, we'll also create a forward and right vector. but these are 3D vectors. So just keep that in mind. That is slightly different than the 2D vector. All right, next up is to check if the camera exists. If the camera exists, we will say forward is equal to the negative global transform basis.z of the camera, and right is the same thing, but of the x-axis. Now, if the camera doesn't exist, this is basically just a fallback to use the exact same thing, but it's just going to use positive values for both. Next up, what we'll do is we'll set the y of the forward and right to 0, because this is just the basically jumping, right? Which in this case, we don't want to jump. Jump is going to be its own state later on. Now, what we can do is normalize these two variables that we just created. Forward.right, forward.normalize and right.normalize. We'll just set it to itself, but normalize it. All right, once we've done all that, we now want to get the desired direction. This basically just simplifies everything and puts it all into one variable so far. So we have our input variable and our right and forward variable that we just got, and we're going to multiply those by each other and normalize it. Now, we will only move if the desired direction is not equal to 0. If it's not equal to 0, then that's where we're going to move. Now, before we start moving, we simply want to also create an accelerate and target velocity. This will basically just allow us to create two different variables that we want that we'll use in just a second. And we use it inside of the player velocity x and z. So here we will use the current velocity of the player, which realistically it'll either be 0 or it'll be slightly higher than the walk state, because the walk state is slower than the run state. So if it is higher, that's totally fine. It'll take whatever value the current velocity is and bring it down or up to the target velocity that we want. It'll also use the accelerate times delta, because this should all be inside of the physics update. Right, now that takes care of moving, but now we want to take a look at turns. Now, first, we'll get the current direction of the player, which is super easy. We just need to get the velocity x and z of the player, and that'll give us where the player is facing. Now, to slow the player down, all we need to do is check if the current direction is not 0. If it isn't, then we will get the alignment, we'll get the turn slowdown, and we'll simply multiply the velocity by those two values. Now, the last part, which is probably the most crucial, is to rotate our player towards the movement itself. So a lot of the time we do use the camera to start our movement, but if I move in a different direction of the camera, that's totally fine, but we need our actual player, so the model, to actually start looking towards our where we're moving. And we do that by getting the target angle, by taking our desired direction, x and z, then we'll get our current angle inside of a variable. We can get the angle difference like so, and finally rotate it by just adding to the y direction, angle difference times rotation speed times delta. Now, we do have a idle state where we already get our player down to 0, but what we want to do is add an else statement for this one right here. This will basically allow us to move towards 0 if I'm not moving. So if I'm not moving anymore, then obviously I do go into the idle, but this will start it prematurely, so that way we can start going to 0 if I exit this state. And lastly, we do want to add gravity, so we'll just do that by adding an if not player on floor. Then we'll take our player towards the gravity by using the function we made earlier in an earlier video, and then times delta. All right, and that is the walk state. If you feel lost at any point, feel free to check my website for more in-depth steps. It helps you build all this step by step by writing it in code in the actual site before actually bringing it into Godot. So give it a look if you are confused. Just a quick explanation on the camera itself. The spring arm is what stops the camera from clipping through walls. It pulls in automatically when something's in the way, basically. And we capture the mouse and use tiny sensitivity values because a third-person camera, Souls-like camera, needs to feel smooth and controlled, not twitchy. Small numbers, but it's a really big difference. Now that our idle and walk state is complete, we will now work on the player camera. To do this, what we'll do is first set up the nodes that we'll need. We'll add a node 3D, we'll duplicate it, we'll make it a child of that one. And then under that, we will add a spring 3D. And this is a very cool mechanic thing, node, that allows us to basically spring arm our camera. And you will see what that looks like in just a second once we actually add a camera 3D. The idea here is that this camera will be springed back and forth if anything is in in between the point of the spring arm and the length of the spring arm. So first we need to set up our camera properly, because right now this is not how it should look. First, what we'll do is we'll rename the first node to camera mount. The next one will be the H, and this will be V. This is basically horizontal and vertical. The idea behind those is that we will use these two nodes to control the camera. So we're going to take one of these nodes and just, so this is vertical, so this will be up and down. So anytime I move my mouse up and down, we will move the vertical of this node specifically. So I'm just going to reset it to 0. Now, to use the spring arm, what we'll do here is inside of the spring length, we'll do -4 and 0.2. Now, the reason we're doing -4 is because we want the spring arm to go behind the player. So here in the camera, because you can see that the camera is actually facing pretty much the wrong way, we'll just rotate the camera like so, and then we will bring up the V and bring this up right above here. We basically want to move it above the player's head. You could move it inside or slightly in front like this, but I find you sometimes get weird interactions with the spring arm. We will take a look at collision mask later, but keep in mind the collision mask does work properly with the collision of any static body or any collision shape inside of our game. So at the moment, the static body is inside of collision. Here we go. In layer 1, you'll see that this is where the camera will be hitting basically. But for now, we won't really worry about it too much. Next up is to create our camera controller script. So we'll do that by creating a camera controller, and we will add this not inside the scenes, but inside of the scripts for our player, and hit open and create. All right, now that we've done that, we are going to want to create a few variables here. So these are all basically just variables that are going to allow us to control the camera movement a little bit smoother using very slight numbers. So you'll notice that the H and V sensitivity are very low, and you'll see why in a minute when we actually add it inside of our physics process. Next up, we will access all our nodes that we need. So H, HV, HV camera player, and keep in mind that this will work perfectly because it is attached to our camera mount. But do make sure that the nodes and the names are the exact same. Lastly, we'll create an isCaptured variable. This is going to allow us to hit escape or not and basically capture our mouse. This is very useful in a lot of games. Many games have this that are 3D. Valorant has this. League doesn't have this because your mouse is always open, but any sort of 3D game where your mouse is your camera, this is usually a thing. All right, so the first thing we'll do is inside of our ready function. There we go. Inside of our ready function, we will create basically just set the rotation of our H pivot to our camera pivot. Same thing for the V spring into the camera rotation V. We'll set isCaptured to mouse capture ready. So this is true by default. Of course, you can change this in the export. That's why we did that. And then we will take our mouse mode and capture it if it is captured. Otherwise, it'll be visible. Now, feel free to test this out yourself, but visible, it basically means you can see the mouse just as it is right now, whereas captured will allow the mouse to be captured inside of the game, and you won't be able to see the mouse anymore. All right, next up is to create our physics process. We will access the parent by saying just get parent. This will be able to access our player. So you could also just name this player if you'd like, but we'll do that and take our global position and set it to the global position of the player. So it's basically going to allow our camera to follow the player despite it being a child anyways. This will just allow for smoother movement. And I will show you in just a minute why we'll do that. But for now, let's just finish the physics process. Now, we added 3 lines, but this one will actually come back to in just a second. But what's important is that we are now rotating the Y and the X of our 2 arms. This is going to just be a simple lerp from our current rotation to the rotation of our H, which we are going to edit inside of the input function, which obviously we don't have. But now going back to this one is important because this is clamping our rotation vertical between 2 numbers. These 2 numbers are basically the degrees that I've set. Of course, feel free to play around with these numbers. These are very flexible. But the idea here is whenever I am behind my camera or my player and I want my camera to be under a certain point, or I don't want it to be under a certain point, that's why we set that clamping. Now, obviously, I don't want my camera to go all the way up above my character. So again, we clamp it at a certain angle upwards. Now, this will basically take care of the actual rotation and the clamping of our camera, but we don't have any input yet. So let's create some input. Input can be done very easily by just adding an input function, checking if the event is a motion, and if the mouse is captured. This is very important because if it's not captured, then we don't want to move the camera. And then we'll simply add to the camera rotation H and V using the event relative X with our sensitivity, which we added earlier. Now, this is basically, again, just to control the sensitivity of our camera. Now, lastly, we will add the way to change our mouse is captured. This will basically check to see if we press the toggle mouse capture. If so, we use the function switch mouse and basically switch mouse is captured to whatever it isn't at the moment. And then again, we'll have to update the mouse mode into captured or visible. Just to make sure that we have done this properly inside of our input map, we need to make sure that we have the toggle mouse capture. Again, this can be anything, but usually it is escape. But now, whenever I hit play, let's test this out. And there we go. We can now use our camera and move it around. And when I hit escape, my mouse now appears. If I hit it again, it kind of goes back into the game and I can go in and out. This is a nice, smooth player controller. To start off our input controller, we first want to edit our state machine script to add. All right, before we move on, real talk. This is going to be the hardest section in this series, so don't get discouraged. We're building one central input code for everything. The mental model, the controller reads raw input once, decides what action it means, and the states just ask what I should do. If it gets confusing at any point, pause, rewatch, and check the written walkthrough on the site. You've got some things before we actually get started. The first thing is we want to add two new variables inside of here. One we actually already have, and the second, well, we're about to create that in a second. The animation tree and the input controller. Now you'll see that we have an error, and that's because we didn't create this class yet. So just to get rid of this error, why don't we go ahead and do that? I want you to try to pause the video actually, and try creating that class script yourself. So what we'll do is go into the player, new script, we'll say input controller, and it already exists. So let's go ahead and open this file. And all we need to do is say class name input controller and just save. For now, we won't add anything just yet. We can actually just drag this up to the top, drag up our state machine, because that's what we're going to be editing, these two files. Back inside of our state machine, we're going to add a few things. Inside of our ready script, or inside of our ready function, we want to add one more new push warning. This is basically the exact same thing as the player, but it's just for the animation tree now. Next, we're going to add 3 new functions that are going to help us set up the environment. We're going to add setup input controller, setup states, and enter initial states. Now, of course, we don't have any of these yet, so we're going to get 3 errors. So why don't we go ahead and start with one of them? Right here under the ready, we'll just create some new space here. And the idea behind this, function is simply to just get our input controller and add it as a child. If it doesn't already exist, we'll create it and add it. If it already exists, then we just get node and that's it. We also want to make sure we set up the input controller state machine and player, which we will add inside of our input controller in a minute. But let's continue off the other functions that we need. First, let's go ahead and do the enter initial state. This is simply to see if initial state exists, meaning if it's not null, then what we will do is simply enter that initial state. Now, if you recall, we actually did that in a previous video by setting it to idle. But if that doesn't happen and we don't have this, as a fallback, we have the idle state. So we'll just get the idle state and basically set that as our current state. So this way, if we have an initial state set or not, we will always enter the idle state. Now, realistically, you could just make do with this and not even have to export this. So of course, it is just up to you. I kind of add it as a learning thing just for you guys to understand the reason why we add this. Okay, and now our last function is the setup states. Now let's go through this one a little bit slower. First, we define the function, and what we want to do is for loop the children inside of the children. So child is just to keep track, but it's a good word. So for child in the children. So basically, we're going to be looking within the children of the states, and we're going to be looking for a state. If child is state, and child is not input controller, then all we need to do is set it up. Now, this looks like a lot, But trust me, it's not. Basically, all we need to do is first we need to actually get the name of the state properly, and we do this by lowering this capital case. Then we get the states of the state name equal to child. If the state name ends with this state, we will simply replace it with that state. And then, now the last part, this again looks like a lot, but it's super simple. All we need to do is set the variables up inside of that state. So we'll get the state, add the state machine, and equal to self. So basically, if we have idle, we will get the idle to have these basically the idle's state machine. Basically, the idle has a script, right? It has a state and it has variables, and we need to fill out these variables because they're all empty right now. So inside of this setup, we're simply filling them out, and that's it. Now, the last thing that we'll do is set up the animation tree, and we do that like so. We just check for an animation tree, and if it's active, which it should be, and then we'll just get the playbook by getting the parameters./playback, and then setting the animation player to the playbook. And that's it. This will allow us super fast access to the playback of inside of each state for the animation player. Now, inside of any state, we have the animation player as a playback, and we can simply travel to it super easily, which we wrote this earlier. Okay, there's one more thing we're going to add before we move on, and it's actually very similar to the physics process. All we need to do is create something that handles unhandled input. It's kind of a mouthful, but basically inside of the current states, we're going to be adding a function called handle input, and we need to just do the exact same thing where we just get a function that checks for these inputs, and we just do this by handle input event. Now, one more last thing, I keep saying one more last thing, but this is truly the last thing for this part in this video. Oops, I wasn't supposed to exit there. At the very bottom of our script, we're going to add a function. It's basically a helper function that gets the current state name. And that's it. So it simply gets our current state name to return to wherever we call it to know, hey, this is the current state that we're in. So it's just a helper function for later. All right, now moving over to our input controller, we now want to set up some of our variables that we're going to need. The first two are player and state machine. We'll also create movement input, is sprinting, is using controller, and input strength. Now, obviously, this is just for if we're using a controller. This is sprinting, meaning this is going to help us transition between move or walk and sprint. Input strength is going to be specifically for the controller, so we'll kind of come back to this when we actually implement this. We'll also add an analog dead zone and a sprint threshold. The first thing we'll add is our process function, which will basically just check to see if state machine and player exist. If they don't, then we'll just return. If they do exist, we will then pull inputs and input handle movement input. This is basically to queue our input, and this is actually the guts of a Souls-like movement character. But why don't we just add these functions in so we can actually check out what they do. So pull input will simply check to see if we just pressed jump. If we did, we will handle the jump. In this case, what we'll do is create a function for that. For the handle jump function, again, we want to just check to see if the current state machine current state exists. If we are actually in a current state. If we're not in a current state, this could happen. This is actually very common where we just started the game and the player or the user, the person playing the game, presses the spacebar. If they do this and we haven't initialized our states yet, then we might get some errors. And that's why we have this if statement. After that, we basically want to check to see if we're currently in the idle state, the walk state, and the run state. If we are, then we will jump. Now for the handle movement input, we basically want to handle movement. And we do that by getting raw input, by getting a vector, which I believe we did this earlier. So this will just allow us to do this inside of the input controller. Now what we'll do is we'll add a is using controller section. So this part is going to be overriding the raw input if we need to. Now we do this by it's kind of a built-in function inside of Godot where we say get connected joypads.size bigger than 0. This means that we have a connected joypad and we are going to look for the joypad's strength. And we do this by checking the get axis. Now, the reason why the strength is a little different than the raw input is because the joypad can actually detect between 0 and 1, whereas your keyboard is only 0 and 1. right? So if you are pressing a button on your right hand side, it's you either are or aren't, right? But a joypad can use the joypad thing to detect if it's actually between 0 and 1. Now we will check to see if the raw input dot length is less than the dead zone. Now the dead zone is relatively small, 0.1, and this is basically like on the joypad, sometimes you might leave the joypad a little to the right or left. It's not really a bug on the computer. It's not a software bug. It's more of a hardware issue. Not all joypads are amazing, and they don't always reset at 0. So what we need to do is take that into account, that sometimes the number between in the joypad will be like 0.01, and we don't really want the player to move if that's the case, because that can be quite annoying when the user is playing our game. So we detect for that by adding a dead zone. Basically, if it's within that dead zone, we just do nothing. Now the last thing we'll do is kind of continue this into some other functions, but basically we'll add determine sprint state, should update movement state, and update movement state. Obviously, this will only happen if we should, but let's take a look at the determine sprint state. Okay, so this will basically have two checks. It's checking to see if we're using controller, first of all. If we are, and it's within a certain threshold, which is 0.75, which is much farther than half. So if you take your controller and spread it and push it all the way, it's basically this. That's kind of the threshold that I like. I found 0.5 is a little too little. That's why I like 0.75. So it's up to you if you want to change this, but that's the number I found that works pretty well. And then if this obviously doesn't work, or if we're not using controller, then that's where we use this. And if we are pressing the sprint button, which in our case should be shift, then that is when we should be sprinting. All right, now for the should update movement, this will basically just check to see if our current state is active once again. And if it is, then we will just return the current state name in idle state, walk, or run. Now, if you're wondering why this return is kind of like in one long line, this is basically returning true or false if the current state is inside of one of these. So if we're in one of these three, then we can continue updating the movement. All right, now lastly, for the actual meat of the movement and updating everything, this is where we get the current name again. So we actually have access to it. And we now check the length of our input. If the movement length is less than 0.1, that means we are idle. So we should transition to idle and then just return. If we are sprinting and the player is not exhausted, which I don't think we've added just yet, we have not, so we will probably add that much later. So basically we won't have this ever for now. Then of course we will transition to run. If we are not in the walk state, then we will transition to walk. The reason we add these checks is because we don't want to waste process time in transitioning to a state that we're already in. Also, there's a bug a lot of the times where if you transition from state like walk state back into walk state, then the enter stuff will happen again. Right? So if you have any code here, which we don't really, then all that code will happen again. Extend state. Actually, we do have the travel state. This won't actually cause any bugs. The animation tree is pretty smart, and it won't bug out if you try to travel to a state you're already in. But let's say you add some stuff in the future, that's when it becomes problematic. Okay, so one more function that we're going to need is to actually get the direction of the movement for our player based on the camera. And we do that with this script. Basically, if the input is less than 0, we'll just return 0. If camera doesn't exist, then we will return the base input or base like movement. So this is kind of just like straight. Now, if our camera does exist, that's where we will get the forward of our camera by getting the basis.sed, but the negative because of the direction that our player is facing is kind of backwards. I just didn't bother to change the direction. So if your player, just FYI, if your player is facing this way, so if you look at the axes over here, this is the negative to the left and the right is the positive. So if your player is facing that way, you would want to change that. Okay, back to the script. And then we'll just get the X, but obviously positive because he is facing the right way on the right side. And we can just return the forward times movement input plus the movement .x and normalize it. Now, we haven't done the attack yet, but this is good to set up now rather than later. But basically, we're just going to match the action This is for later. We don't have this function even implemented just yet, but the match action will if we try to attack and we are inside of one of these three states, then we can attack. Now, we don't want to attack if we're jumping. We don't want to attack if I'm rolling, unless that is an animation that you have. In that case, you might actually want to check for that kind of state, right? Let's say you have a jump attack, where attack that you use in the air. Then what you would do instead is check to see if the state, you would basically just do this. You would add this, but check for jump state, right? If you're in jump state, then you would do some other transition to something else, right? So this is good to understand how this works. If we're in the jump state, or if I try to use the jump action, then I will handle jump, return true, and that's it. Now, if I don't have any of these two, we'll just return false. Now, the last thing I add, and this is for later, but you will see its use now, hopefully, is disable input and enable input. Basically, it's just to enable and disable the input of this entire script. The reason this is so useful is because if I talk to an NPC, we don't want to allow input anymore, right? We want to only allow input for the NPC to talk to that NPC. All right, that is pretty much part one of the input controller. We went through quite a bit. We won't be touching the input controller for a little bit. So do take a break and just take a look at this code, see if you can understand it. If not, again, I have on my website a walkthrough, full walkthrough of all this code. It helps you write it, understand it, everything like that. So take a look at codingquest.io. If not, we'll continue with the video and I'll see you. Let me just quickly clarify buffering because it is subtle. When you press attack a hair before a current animation ends, we don't want to throw that input away. We store it for a short window, around 150 milliseconds, and fire it the moment we can. That's why Souls-likes feel very responsive even though you're spamming your button. Buffering is basically just queuing with an expiration date. If you press it slightly early, then it still counts. And a lot of Souls-likes will use this to their advantage to punish the player rather than reward them. Guys, in the next part. The next step of our input controller is to edit our state machine to allow it to actually do something and work. So inside of our state machine, we first want to add two new variables. We'll add an input buffer time, and then we'll actually add three. We'll add an input queue and then a last hit. Now inside of our ready function for the state machine, we can actually just remove all the for loop and stuff outside of these three functions because these functions now do all that stuff. Now, the next thing we're going to edit is the transition to function. At the bottom, we're going to want to add a call deferred function. The basic idea of this function is it's kind of stopping the code from running until this thing happens. So we're going to process the queued action and that's it. So we're going to do this and we're going to stop transitioning or kind of wait at the end of our transition until this happens to make sure that the transition doesn't like overlap on top of the action. And with that, we can now go into the queue input. Right under this, we'll add a new function called queue input, where we'll get the current time using time.getTicks, and then we'll obviously get the input queue. We'll do this by saying .filter with a function item will return now minus the float of item time, and if it's less than the input buffer. Then we can append the actions inside of the input queue, and we will sort it with our own custom function where priority A is just going over priority B. So essentially what this will do is just take our inputs and sort it from the highest priority to the lowest priority queues. Now you'll see this in action later when we actually add some priorities, but for now this kind of just adds a non-existent buffer. The next function we want to add is going to be our process input queue, where we're going to actually just do the exact same thing, copy that and paste it, and then we're going to call the function processed queue actions. Now we need to make that function, where in this function, this is where we actually process the queued actions. Now, the first thing we want to do, as most functions will go over, is to see if it's empty or if the controller doesn't exist, then we'll just return. Now we'll create a while loop, basically, where we'll loop through one less than 3, or sorry, we're going to loop basically until our queue size is done, but as long as the proceeds is less than 3. Now here is basically where we just try to actually execute the action, where we'll go inside the input controller and try the execute action. And of course, these are where we actually loop through the while loop. Otherwise, we won't be able to loop properly. Now, outside of this, we can create some buffer helpers. Now, these functions are going to be used for later when we actually implement. Now, these functions are going to be used for later when we actually implement our attack states. I had a weird bug, but I just reloaded the project and it got fixed. But aside from that, all we need to do now is add some more helper functions. These are combo tracking. These are for combo tracking, where it basically helps us figure out where inside the combo we are. But of course, this is for the attack state. So we will come back to the logic of this. But for now, just know that we do need these for later. And again, if you see this error, all you need to do is just reload your project and it should be fixed. Now, if we try hitting play, we'll immediately get an error here in the unhandled input. Basically, we're trying to call the function handle input inside of the idle state. Now, this goes beyond the idle state. It actually goes into our state class. And that is, we did not add a function here that we need. And that is the handle input function. All we need to do is simply add an empty function, handle input, and that's it. And that should get rid of our error. Let's go ahead and try it again. All right, now at this point, we can go ahead and test it and see that it's not working. So what we need to do now is essentially debug it. Now, I would like for you to take a minute on your own to try to figure out what is going wrong. Now, this is a very important part here. Now, it might be very frustrating and you'll get stuck a lot and you'll have to read through all your code to understand what is going on. The idea that you want to go through mentally is to read through the code and see what part is getting stuck. Now, I'll help you out a little bit. You'll notice that in our input controller, we are getting input movement and strength, so the input is being detected properly, but we are obviously not moving state because over here you can see that our state is not changing and the input queue is not changing either, meaning it's not being added to the input queue. So at some point in between the input queue and the strength and input movement being detected, that it's not working. Now, I'm going to go ahead and go through the solution to an extent. The problem here is actually that inside the current name, this was actually my mistake, but we added state when we shouldn't have because we were removing it before. So all the areas where we have idle state, idle, whatever, we need to make sure that we're just saying walk, run, etc. It shouldn't say state anywhere inside of this script, and you'll notice that we have it in a few places. So we just need to delete that. And there we go. And one last area, and that should be good. Now we can go ahead and give it a try, and you'll notice we can now move. Now there's other issues with our camera rotation, which is basically our camera is rotating too fast around our player. Well, let's go ahead and fix that next. All right, so we've already noticed this bug where if my camera's up, the rotation is kind of all messed up. Now, if you play around with it, you'll notice that when let's actually replay a little bit. When I have the camera like lower, it actually doesn't seem to be too bad on both actually, on right, left, and forward, right? You'll notice that it's not too bad. But when I move the camera up, that's kind of when things start to angle. And if I move it even further up, it kind of starts to whack out. So that kind of tells us there's a problem with the rotation. I'm going to tell you right now, the problem is not with the code. The code actually is relatively correct, but it takes into account that essentially the camera mount and the player are disconnected. So that's not the case here because we have the player mount attached to the player. It's a child of the player. Now, there's two ways we can fix this. Either you can move the camera mount into the world and have it like over here. I just realized we have this camera over here. Let's just delete that. And the other solution, which is a little easier, in the transform, we simply need to turn on top level. Now go ahead and give it a try, and you'll notice that it works perfectly. Awesome. We now have a moving character. This is so cool. Now, there were a couple debug issues, and that is part of the process. So hopefully you didn't get too discouraged. Going forward, we won't have too many problems. That was actually a very big bulk of like the code that we're going to be using for the player. The controller and the state machine are probably the hardest things to make in the beginning. But now that we have it set up, doing everything else, all the other states are going to be breeze. So I'll see you guys in the next part where we'll do these. Here's why the run state has that exhaustion check. When stamina hits 0, you don't just stop. You're locked out of sprinting until it recovers past a threshold, around 20%. That little rule is what makes stamina a real resource. You have to manage it instead of something you ignore. Tune the threshold to taste, but keep the idea. Sprint. All right, so our next part is to create our script. So what we'll do is simply create run state, open it up, and I'm going to go ahead and actually go into the walk state and copy this as a base because a lot of this is going to be relatively similar. The obvious difference is that this is going to be the run animation, and do make sure that this name fits with your animation tree with this name right here. So the run animation. If you have it as sprint or whatever, do make sure you write that instead. Now at the top, we're going to replace these variables with different ones: run speed, excel time, rotation speed, stamina drain rate, and current stamina. And we can see here that walk speed is no longer a thing. And that is obvious because we replaced it with run speed. So we'll just replace that. And that is actually pretty much it, because the run speed is higher. So it's already going to be faster than the walk. But there is another issue, or another thing we're going to add, which is going to allow this to actually feel a bit more like we're running. And that is to actually get the stamina to be used. And we'll do that by saying current stamina minus equal stamina drain rate times delta, player.stamina is equal to the current stamina. Then, just to double check, what we need to do is make sure that if our stamina is 0 or less than 0, we'll just return to walk, the walk state. And that is pretty much it for the run state. Super simple, pretty straightforward. We've already done most of the logic for it. All we need to do now is add it as a state. That is not the right one. So let's make sure we add the run state, which it doesn't exist. And that is for a very good reason, because the class name is walk state. So we need to rename it to run state. Now, when we search up run, it'll show up. Now we have the idle walk run, and now we should be able to test this out. And now you can see when I hold shift, my player starts sprinting, and eventually I should get tired. Okay, so there is a bug, and that is transitioning back from the walk, or from the run to the walk. It seems that even though my stamina is 0, I'm not transitioning back to the walk state. It seems I'm just staying in the run state, but I'm not actually moving. So it's kind of good and bad. So let's take a look at what's going on. Okay, so the way we can actually kind of test this is you can see on the bottom that I am printing the current state. And we can see that I am in the run state. And when I finish, we actually go into the walk state. It's printing the walk state. Now, there's two issues that kind of caught from this. Basically, we are going into the walk state, but there's another issue. Back in our run state, for our current stamina, we redefine this at 100, and it does kind of work, but the problem is it never resets every time we enter. So either we can reset it here, or what we can do is replace these two lines with 1, and we won't even need the current stamina, which will basically just say we'll reduce the stamina by the stamina drain rate times delta. Now we can just remove this right here, and then we'll need to replace the player stamina with the current stamina with player stamina. Now back inside of our input manager or input controller, we need to find the transition to jump. So let's just search that up. Sorry, here we go. This is where we need to be. This is where we need to be specifically. In this if statement, we'll notice that we're trying to do if player.get stamina exhausted. But if we go inside the player, we'll notice that variable doesn't exist. So we're kind of missing a few features that involve the stamina, and we need to fill that. And one other thing I just noticed is this right here says run state, but we actually just need to say run. So what we'll do is we'll add two new variables: stamina recovery threshold and stamina exhausted. This is a Boolean, and this just tells us if our stamina is exhausted or not. So the cool part about this is back inside of our run state, we're going to simply add a condition here saying player.stamina exhausted equals true before transitioning into walk. Now this will trigger inside of our input controller. So now this will return true if it is exhausted. But back inside of our player, we need to add to the process. And all we need to do is say if stamina is exhausted and stamina is greater than the recovery threshold, then we will say it is false. So this will only set it to false if it's true and if it's greater than the threshold, which in this case will be 20. So this way we won't be able to just run if our stamina is less than a certain amount. Of course, the threshold, you're able to do whatever you want. I find low numbers like 10 might work better, like 10 to 15, but it does also depend on the amount of stamina that you're using. And if your game is going to have stamina upgrades in the future, which a lot of Souls-likes will have that. So of course, it is up to you on how much you want this number to be. But with that, let's go ahead and test it now and see if this actually works. So we're going to run around a little bit, and after a bit, we'll notice that I can no longer run, but I'm holding shift right now, and you'll notice I go kind of between walk and run, and that is because every time I have enough stamina, it'll just go back into the run state. But if I let it just walk for a bit, I should recover my stamina, and now I can run around a little longer. Awesome. Now with that, that ends our run state. Now feel free to, I just noticed this texture button. I'll just delete that. We don't want that there. Feel free to add a stamina bar if you'd like, but we will be covering UI at some point in the near future. But for now, I will see you guys. Two quick clarifications here. First, why a separate fall state instead of one jump state? Splitting them lets us treat going up and coming down differently, and it's where you would add a double jump later if you ever wanted to. Second, when we land, we go straight back into walking or running instead of bouncing through idle state. That tiny shortcut keeps moving feeling instant instead of very joggy or laggy. That's what makes the difference between a Souls-like and a regular RPG. The next part, now that we've finally finished the walk, idle, and sprint state, we now want to do jump and land. I'm going to duplicate the idle state as a start. I'm going to do jump state, duplicate one more time, and we'll add a landing state. Make sure you rename both class name states right here, jump state and land state. And now we won't have any errors. We'll start with the jump state. So this is the essentially going upwards. In here, we're going to need 5 different variables, and I'm going to replace the current ones with jump force, air control, move speed, tracking angular speed, and has jump. These are all very useful variables that you'll see how we implement it in just a minute, but most of them do exactly what it says. So this is the initial jump force that boots us upwards, basically. This is how much control we have in the air. This is how much we're allowed to move in the air. And this is the angular speed, which we're allowed to rotate in the air. And these are all very good variables to actually allow us to control. And I do also suggest you play around with these numbers. I've just kind of added whatever I feel is best and whatever feels smooth to me. Now we can go ahead and delete most of this code. We'll start off by saying if has not jumped and player is on floor, we can add the velocity to our player. Now this is a very, very basic jump. It's actually the same code as the default, where we basically just set the velocity of y equal to the jump force. And of course we need to set has jumped equal to true. Now, pretty much all that's left is to add the gravity, which we do right here. And if our velocity reaches negative, this means, like, if our velocity is negative, that means we're now going downwards, which should mean that we're falling. Sometimes we might not be falling immediately, but usually we will transition immediately to fall. And we will add conditions inside the fall state to make sure we account for any other like issues. Now, the next part, that tricky part, is going to be the air control. Now, some of this code you've already seen before, but basically we need to get the input direction from the input controller. We'll check to see if there's a camera. If there is, we get the right and forward. From there, we make sure to set it all to 0 and normalize it. Now, at this point, we'll basically do very similar logic to what we did in our camera, but this is just to rotate a little slower, essentially. That's basically all it is. It's to use our tracking angular speed. That's pretty much all we're doing. We're just kind of overriding the player rotation rather than using anything else. And that's it. This is our jump state. From here, though, we're going to need a fall state now, because you'll notice that we're transitioning to fall. So let's go ahead and duplicate our jump state and say fall. Open up the fall state and replace the class name with fall. We are going to need similar variables. We're not going to need has jumped, and we're not going to need jump force, but we will need these 3. So just keep those. One other thing I just realized I forgot is the animation. So make sure you set the animation in here and the jump state. Over here, we'll say jump. I believe it's jump start. Let's just double check with the animation tree. Jump start, jump loop, and land. So that is correct. And go back into our fall state. And our fall state is actually going to be the exact same thing, but without the jump. And of course, if the velocity is, we don't like negative than 0, we don't need that. We need something else, which is if our player is on the floor, then we transition to landing. And that's it. Our fall and jump state are complete. It's pretty simple because both are pretty much the same code. We just need to remove the jump from the fall state. Obviously, it'd be kind of weird if we're jumping again in the fall state. Now, we could add conditions to double jump inside the fall state. So keep that in mind. If you ever want to add double jumps or triple jumps in your game, you can either add that in the fall state or jump state. I do personally find it better to add it in the fall state. When I made platformers, I have other series on my channel if you guys want to check that out, where I add double jumps, triple jumps, and it makes the game feel a little smoother when we add a double jump inside the fall state rather than the jump state itself. And now for the landing state. This one is much, much easier, so don't worry too much. We're simply going to add a landing duration and a landing timer. And inside the animation name, we're just going to change it to land. When we enter this state, though, we want to half our velocity. This kind of slows us down. This will basically just make sure that whatever velocity I had gets cut in half, because whenever we land, that usually should kind of stop us from running, right? Now, inside of the physics update, instead, of course, we'll take our current velocity and bring it to 0, and we'll do that for the X and Z. And of course, we'll make sure to add gravity if we're not on the floor. Obviously, this shouldn't happen since we're on land, but if this ever bugs out, it's always important to have like a backup for whatever might happen. Now, that is kind of the bulk of this code, but there is one more thing we want to add in here. And we're actually going to override the update function, which we have inside the state. So right here, we have this function, but we're actually going to add to it. So right now, that function basically has nothing in most states, but in this state, we're going to add a check. And what we're checking for is if the landing timer is less than 0, and if the input controller is less, if the input controller movement input dot length is bigger than 0.1, this means that we're actually trying to click something, right? We're essentially trying to put in movement. Then, well, we want to move, and there's 3 options. If we're sprinting, then we run. Otherwise, we walk. Now, if I'm not doing any input, that means I'm just going to transition to idle. And that kind of gets rid of our transitions out of the landing state. You might have noticed inside the physics, we didn't add anything like that. Now you could, of course, add a transition into idle after the animation's done. That's totally an option. But the advantage with this is that we're not wasting time by going from idle to walk, from land to idle to walk. This way we can immediately transition from land state into run state if we want, or into walk state. So imagine if we're going from land to idle to walk. We were kind of wasting a bit of time transitioning to idle state before transitioning into walk state, right? So we would want to transition immediately to run or walk. And of course, if we're not doing either of those, to idle. And that is it. So let's close our scripting and give it a try. And immediately I'll notice that it's not going to work because we didn't even add the states that we just created. So let's go ahead and do that before we actually try testing anything. Let's add jump state, land state, and fall state, and make sure to rename them with fall, land, or rename it to whatever you have your code set to. So mine is just idle, walk, jump, etc. All right, so there is a bug, but most of it did actually work. You'll notice that this is actually the fall state. So it looks like we're stuck in the fall state, but it does seem like the jump state worked, but we're just going to double check before we stop the game. So if we go to the current state, we are stuck in the jump loop. So that should be the fall state. So essentially we're stuck in this state, and it's pretty obvious the problem here. It seems we're not transitioning because I transitioned to something wrong. So let's make sure we fix that and try again. And there we go. We just implemented a full jump state. Oh, it seems like there's another bug. We don't seem to be jumping properly anymore. So let's take a look at what's going on there. All right, the issue is the jump state has jumped equals true. We never set it back to false. So we need to do that inside the enter, and that should fix our problem. Super small bug. That was a little oversight on my part, but now we can jump over and over again. And you'll see that little stutter that when I land, it kind of stops my player essentially, but I can transition immediately from the jump into a running state immediately. And it's pretty smooth. But yeah, of course, you guys, I do encourage you guys to play around with the fall land things, especially the duration of the land. I found 0.3 pretty decent, but if you make it shorter, that's fine too. If you make it longer, that's also okay. It kind of just depends on how you want your Souls-like to work, because the jump itself is actually a pretty big part of Souls-likes, because that gives the player less time to react to things, right? Because you can't interrupt that landing animation unless you decrease this number. So that's pretty much it. I'll see you guys in the next part for building our world a little bit. All right, so at this point, we've added our player, but you'll notice our scene is pretty ugly. It doesn't look very nice. And it doesn't look the same as here. And I'll show you why, and then I'll also explain, I'll show you how to create this scene, and then why. So first we need to add a world environment. This will immediately make our world different. And the reason why this wasn't like this is if I delete this world environment, you'll notice this right here, the toggle preview environment. This is toggling as if we have, I wouldn't say the ideal environment, but it's kind of the default. It's just like a sky and whatever. And that's exactly where we're going to set up. So we're going to create an environment here by saying new environment, and we're going to go to background. We're going to go to sky, go into the sky, and make sure we actually give it a sky material. We'll do procedural, and now our scene looks pretty much the same. And at this point inside of our game, it does look better, but you'll notice it doesn't look exactly the same. And there's even a shadow inside, and ours doesn't have that. And that is because we need to add a light. If we add a light like directional light or omni light, let's do directional light for now. And I bring it up, you'll notice the direction is going straight to the right. But if I bring it down or even at an angle a little bit and hit play, you'll see our world has brightened up much, much more. And if you want to enable shadows inside the directional light, you can turn on shadow, hit play, and now you'll see our shadow from our player. Just a quick note, I wouldn't recommend using shadows too often. With directional light, I wouldn't recommend turning it on at all, mainly because this will add a shadow to every object in the game. There are ways of optimizing in 3D. At the moment, you will notice that there's any difference in performance. You're probably working fine. Just a quick checkpoint. Look at what we've got. A fully animated player with idle, walk, run, jump, fall, and landing. Camera relative movement, a 3D person, a third-person camera, a centralized input system with buffering, and a stamina system, all on a clean state machine foundation. That was a big mouthful, but it's a lot. The character feels good to control, so congratulate yourself, pat yourself on the back a little bit, take a break if you need to, but now it's time to make him a little bit more dangerous by adding some attacks. And that's because we only have a player and a block. But as you expand your world and you add many, many more objects, the game will lag very, very fast. So do look into optimizing videos or optimizing 3D if you want to look up videos, or if you want to check out my channel or on my website. I should have some 3D optimization videos coming soon. By the time you watch this, it might be already out. So go ahead and check it out if you want. Now that we finally have relatively smooth movement, with a really cool jump, this is the part that turns a character controller into a Souls-like combat. We're building an attack system, a 3-hit combo, a dodge roll with invincibility frames, a hit reaction with knockback, and a death and respawn flow. It's the biggest payoff of the entire controller, so let's get right into it. Sprint, we have a stamina system. We now want to add our attack system. The combat system is going to be the final part of our player, and a little bit of on the harder side, not because it's relatively difficult, but because there's just a lot to it. So we'll go by step, and of course the first step is to start off with the attack state. So we need to actually make the attack state script. We'll open it up, and I'm going to go ahead and actually just start off by copying some of the basics that we'll need into here, and of course we need to change this to attack. To start off with, we will have 4 different variables: an attack duration, recovery duration, attack timer, and in recovery. Now, the attack duration is actually relatively dependent on the animation itself. Now, this took me a little bit of testing, not too much, but the basic idea here was in the actual attack animation, when I went to play my attack, I'll bring this down a little bit, and I realized we actually haven't connected our attack, but we'll take a look at that in just a minute. Let's play one of these attack animations. You can see that it's about 1 second, and most of them are relatively longer than 1 second, but the idea is that they're relatively slow actually. So what we're going to do is we're going to speed up these animations, and more than that, the actual attack, we don't want it to lock the player more than this amount of time. Just a quick design choice to call out up front, specifically for Souls-likes, is that our attacks are committed. The moment that you swing, you're locked in for that swing. You can't instantly cancel out, and that's intentional. If you play Souls-likes, you'll know that whenever you click the attack button, you're now stuck in that animation. That's exactly what makes Souls-likes combat very intense and kind of rewarding when you actually win. Every swing is a real decision with risk that comes with it. It's not just a button that you smash until you win, right? We'll soften it up slightly with buffering, but the weight will stay. But for the rest of it, the recovery duration is where we can recover after this amount of time. The attack timer is just to be able for us to know where inside the attack we are, and in recovery is a true or false, basically if we are in recovery or not. The next thing we'll do is set up the animation name. We'll get the attack timer to be the attack duration, and the in recovery, we're going to set that to false, because if you remember, we had a similar thing in the jump state, and we forgot to set it back to false in the enter state. So this time we're not going to forget to do that. When I say we, I mean me. All right, so after that, The code is relatively simple, actually. All we need to do is say attack timer minus equal delta. Now we could do a multiplication here. We could say add like another float and do a multiplication, but delta works totally fine. And then the attack timer, if the attack timer is less than or equal to 0 and we're not in recovery, then what we will do is say recovery is equal to true. Attack timer is equal to the recovery duration. So this is how much I have to recover after the attack. So 0.3 seconds. It's pretty short. It's we need this short enough so that you don't really notice it, but it's not hindering the player combat itself. And then elif, so else if the attack timer is less than 0 and we are in recovery, then we'll transition into idle. So this is the transition out of the attack state. And we don't need to mess with velocity or anything. We can, and we probably will later on, mess with velocity. But for now, this is totally fine. And this is all we need. All we need to do next is copy paste the attack one. We'll exit the script. And we're going to go ahead and set up the animation tree and finish setting up our animations. So I want you to go ahead and pause the video and try to set everything up without my help. All right, so I've gone ahead and added all 3 attack combos. And the way I did this is just by right-clicking, add blend tree. Inside, I'll just delete this one and I'll show you inside of this one. I've added the melee attack chop, and number 2 is going to be the attack stab, and then attack 3 is going to be the spinning. Just a quick note, you'll notice that there's one-handed and two-handed, and that is because the asset pack comes with a shield. I'm not sure if this character has a shield, but of course you can just wield it by putting it onto our character. But the idea here is that we're going to be able to transition from idle, walk, run into attack 1, where we do this attack slash, and then attack 2 will be a stab, and then number 3 will be a spin. Now, there is actually something we need to do here, and that is by going into the spinning, we need to loop this, because this will need to be a loop where he constantly is spinning. Now, we will notice that it just looks weird because he doesn't have a sword. So let's go ahead and add a sword to our player. Inside of the K-Kit Adventures asset, we can find the FBX. You'll find a bunch of weapons, daggers, axe, etc. And you can go ahead and pick whichever one you want. I believe the dagger was in one of the demos I used. But since we're using the barbarian, we might as well just give him the axe. For now, we can just drop it right here. It won't matter too much in just a second, because what we're going to do is we're going to add a bone attachment 3D. This bone attachment 3D essentially attaches itself to one of the skeleton 3D's bones. You'll notice on the right-hand side of our screen, there are a series of bones, and some of these represent what it actually is inside of the skeleton. And if I actually stop playing the player for just a second, go ahead and play the idle and go hover the skeleton 3D, you'll notice that we can see the outline of the skeleton. And without knowing anything about Blender or skeletons or animations, you don't need to know too much. All you need to know is that this is a literal skeleton, and these all represents the bones of the player. And you'll notice that it acts exactly with the mesh of the actual model. So what we not want to do is we want to have our bone attachment 3D connect to one of these bones. Now, if you don't see a bone name, that means the bone attachment is not a child of the skeleton 3D. So go ahead and make it a child of the 3D. If you try adding it in, so let's say it was over here. So let's say it was child of the rig. You'll notice immediately I get an error. Let's say you try adding it in here and it doesn't fix itself. You can just try deleting it and then adding a child again by selecting the skeleton 3D and add it again. I've noticed sometimes that there is some bugs with that inside of Godot, so just in case you guys had that issue. So let's go ahead and pick either the wrist right, hand slot right, or just something in his hand that's on the right hand side. So I'm going to go ahead and do hand slot. And now we can take our axe, make it a child. I'm going to actually make this local here. So I'm just going to take the mesh of the axe, delete the node, and we're going to make the mesh a child of the bone attachment. We can go ahead and just rename this to weapon hand. And in the axe, you'll notice that it didn't really position itself properly yet. So all we need to do is go into the transform, reset the rotation of everything. Probably not the scale, actually. That wouldn't make any sense. And that's it. It kind of looks like it's in the right position, but of course not really. So we need to fix it by just rotating it, I believe, just until it looks like he's holding it. And we can actually move it just a little bit more, so it's actually on the handle. And there we go. Now it looks like he's holding it. So now what we can do is go ahead and try playing an animation. Now it looks like he's actually playing it. Now inside of this animation, sometimes you might not like how it looks, and that's totally fine. So what I end up doing is turn off the active in our animation tree, go back into the animation player. We're going to go halfway through this. And the reason we're doing this is just so I can catch my player at mid animation and adjust the axe and the rotation of the axe to how I like it. And I kind of don't like that it's slanted, so I'm just going to bring it up a little bit and rotate it just slightly. And of course, I need to make sure that this is working properly in the chop. And you'll see it looks pretty good. It looks smooth. And the slice as well. The slice is not the one we use the stab. Stab might look a little weird since we're using an axe, but it's totally fine. Monster will take damage from a stab like this. And there we go. That's our animation. We now have a weapon and it's all connected. So let's turn back on the active on our animation tree. And now we have everything activated. All right, continuing on in our attack state, we want to now check for buffered attacks. This basically means we're looking for combo attacks. So inside of our here elif statement, right before we transition to an if statement, we want to check for something else. And it's actually really simple. All we need to do is if has buffered input attack, then consume buffer input attack. And if you may recall, we did that when we last worked on the state machine. We added these buffer helpers, and that is exactly what these do. So inside of the has buffer attack, we're basically just looking for an action. So if this action that we just put in, so in this case, we just ask for the attack action, then we will return true. Otherwise, we'll just return false. Now the consume buffer input, it kind of just does the same thing, but consumes it, meaning we remove it. We remove it from the array. Going back to our attack state, we now also want to add some actual functionality if we do have an extra buffered attack, and that is to say attack timer equal to attack duration. Now this is basically resetting the attack inside the attack animation, or sorry, the attack state. So let me quickly re-explain that if that didn't make sense. Essentially, we're staying in the attack state, but we want to redo the animation. We want to redo the second animation. That's the idea. We want to now go to attack 2, and we will edit the attack animation in a minute. But for now, there is something else that we're missing, and that is the actual input for another attack. And this is also relatively easy. All we need to do is look for handle input, and we can just check for an attack. If we do have that attack, or if we do press it, sorry, then we just queue the input inside of our state machine. And that's it. Super simple. All we had to do is check for a few things. We have these helper functions already inside of our state machine. So it's pretty easy and simple. And before we end this part, just make sure we add the attack state. And we're not going to test anything just yet, but we're just going to make sure we add the attack state before we forget. All right, at this point, we want to go ahead and test it. And I'll tell you right now, it's not going to work. And that is for a very, very obvious reason. Hopefully it's obvious. We haven't added anything in the input controller to allow us to move into the attack state. So what we'll do is inside the poll inputs, right here, we're just going to duplicate this, and instead of jump, we'll do attack. Instead of handle jump, we will do, handle, what am I saying? Handle attack. And obviously we have an error here, and that is because we need to handle the attack. And this is pretty simple. We can actually just duplicate the handle jump, but we will do handle attack. We're going to replace the has method with, we're going to have the same thing, has method, but we're also going to check if the current state is not attack. We also need to change this to attack. This will allow us to actually transition into the attack state. And that is it here. One other thing we need to add, though, is inside of the try execute action function, we now also need to check for the attack. So we'll go ahead and just duplicate this, and we'll type in attack. We'll leave the condition because it's the same. And all we need to do is transition to attack. And now you can see we can go ahead and play the attack animation. There is a very big problem, though. You can see that I got cut off short, and that is for two reasons. One, well, it's one reason kind of conjoined. The attack duration is 0.5. So if you want to increase that, go for it. However, instead of doing that, what I'm going to do instead is I don't like the speed of the animation. So we're going to add something inside of these attack nodes. Inside of each one, we're going to go ahead and add a time scale, and I'm going to multiply them by 1.5. This basically speeds up the animation by 1.5. Now you can go ahead and increase this or decrease it. 1 is the default, by the way. So if you want it, if you don't want this at all, you can just leave it, or you can just keep it like that. But I'm going to go ahead and add a time scale to each one. All right, so I've gone ahead and added it to each attack. And now when we go ahead and play, our attack will just attack faster. You will notice that you'll see how it kind of ends abruptly. And that is because, going back to our animation tree, the node going from the attack into the idle, sorry, the transition, so like from here to there, so this one, you'll notice the X fade is 0. So we want to go ahead and do 0.2 for each of these. So we'll go ahead and do that for each of these. I'm going to do that on my own time. Hopefully you can find the time to do that as well. And I'm going to go ahead and see you in the next part. But you'll notice that it is now very smooth and it looks really nice. We now have our, just a heads up on the combo system because it's a little clever. Instead of 3 separate attack states, we keep all 3 hits in one state and track which combo step we're on. Press attack again inside the combo and it queues up the next swing. If you miss the window and it resets, well, less code, and chaining attacks feel responsive instead of clunky. Player attacking, but there are a couple problems. You'll notice that the player keeps moving forward in the attack animation, and that is a very big problem. But don't worry, we're going to fix and change quite a bit actually in this part. We're going to be removing quite a bit, but we're going to go ahead and replace it with a better system. The first thing we're going to do is change all the variables. All right, there's quite a bit here, but let's go through it. We're going to add a constant, a max combo int of 3. We're going to add combo 1 to 3 duration. This is the length of the animation itself. I've done the math, and this is 1.5 of the original attack duration, or not 1.5, sorry, it's the opposite. So it speeds up the attack, and this is the animation length if you multiplied it by 1.5. If you did not multiply your animations by 1.5, you simply need to use the animation length of right here. Okay, just in case you're wondering where these numbers came from. I didn't just pull these out of nowhere. Now the cut time, this kind of, I wouldn't say came out of nowhere. Don't worry about the 6.7. Ooh, 6.7. That is actually a little less than this. That's all. So this, I just made sure that these are cut times of the duration itself. So these just need to be lower numbers than the duration itself, or wherever you want the animation to be cut off if we are going to the next combo. So I've done these numbers by feel. Now the impulse is the amount we're moving during the attack. So you saw our player is moving forward during the attack, but that's because there was velocity from our previous state, from our run state or our walk state. Now don't worry about that. We're going to fix that later. But this is the actual impulse we want for our attack to have. And then stamina cost. Our attack should have a stamina cost. So we'll add this combo, current combo, combo window open, and attack timer. Now you'll see a lot of errors, and don't worry, we're going to be changing quite a bit of here. The first thing we'll do is add a ready function with the attack 1, and then can move is equal to false. We're going to do this in the ready for a very specific reason, and you'll see why when we edit the enter. Or if you don't worry, I'll explain it as we go along. So first, let's delete the animation name. We're going to be updating that later anyways. But inside of the enter, what we're going to do here is we're not going to have these either. We're just going to do the increment combo inside of our state machine. And we don't have that yet. So let's go ahead and actually do that after we've done the enter function. All we need to do to finish this, though, is to have our attack timer and combo window equal to true. We'll also do get combo duration. That'll be a function inside of this area, but we're gonna get to that later. Going to our state machine at the very bottom for the buffer helpers, we're gonna add a couple more helpers, and that is combo helpers. We're gonna basically do get combo count, where we return the combo counter, and now we have an error because we don't have the combo counter. So let's go ahead and add that at the very top. We'll go all the way up here, add combo tracking, and that's it. I don't think we have to worry about this just yet. I think this is just a reload error, so don't worry about it. It's not even, yeah, don't worry about that one here. Okay, under the function enter, we'll also add a function exit. This is basically, I mean, the same thing, but exiting the state. We're going to exit, and then we're going to combo window equal to false. This is actually important this time because we're not actually changing states when we combo, because one might think that we can add 3 different states, and you could totally do that. You can totally add attack combo 1, attack combo 2, attack combo 3, whatever, and that'll totally work. But in this case, we don't need to do that. We can have all the logic of the attack, all the 3 attack combos in here in this one script. Now, instead of inputting the attack, we're going to actually input combo attack with 2. And then scrolling down just a bit, some of this logic we're actually not going to need anymore. And I say some of it, I mean all of it. We're going to actually delete all of this logic that we just wrote. But don't worry, we're going to have the idea in the back of our head for later. So it wasn't a complete waste of time as long as you understood the code. But now we actually want to get our function update. And in here, this is where we're going to change this right here, this line of code. We're going to bring it over here, and we're going to do a little bit more. We're going to first get the elapsed time. We're going to do that by getting combo duration minus the attack timer. And then we're going to check for the combo window open and if the elapsed time is bigger than the get cut time. If the combo has a queue, then we'll execute. Basically, what this means in English is if we have a combo inside of our input, then we're going to actually execute that combo. Now we're getting a lot of errors, so let's see if we can get rid of some of these. Before we do that, actually, let's just finish this function by adding this last line of code. If the attack timer is less than the get combo duration times 1.15, then we'll finish the attack. And the finish attack will add later as well. But for now, let's finally get rid of these errors with the get combo duration first. And these functions are actually helper functions, and they're super simple. It's basically going to return the combo duration of whatever current combo we're on. So we're going to do match current combo. So if you remember, we have the current combo over here and we're keeping track, and we're just going to return whatever number we're on. Now we're going to do the exact same thing, but for cut. So it's the same thing, but for the cut time. And then lastly, we're going to do the same thing, but for the impulse. So I want you to actually go ahead and pause the video and create another helper function that you think will help return the impulse. So just a hint, it's the exact same thing, but just the impulse. All right, and there we go. So it's the impulse, same thing, very simple. And that's all. And before we go back into our code and fix this other error, let's go ahead and add one more helper function as queued combo. This function is actually very similar to the state machine at the very bottom where we has buffered input. It's very similar. It's basically just checking to see if we have the combo attack. If we do, then we return true. If not, then we return false. This is kind of seeing if we're just queuing an attack combo or not. So if we attack twice, like if I'm trying to press my mouse, if I'm spamming my mouse trying to attack, like I'm hitting the monster, that means I'm trying to queue 2 attacks or 3 attacks, right? This is what we're checking for essentially. Now we can fix this issue right here really fast because we don't have the right delta name, but we still have the execute combo transition. So let's go ahead and fix that at the bottom as well. We're going to go ahead and add the function execute combo transition. We're going to for loop through the input size -1 by all the way to -1 by 1 by incrementations of 1. So basically we're just going to for loop through the queue size of the input queue. Okay, if we have the combo attack queued, then we're going to remove it from the input queue and break, because we don't want to remove all of them. We just want to remove the one. Next, we're going to check if our current combo is less than the max combo. This basically means I'm not going over the amount that I should be. And if so, this is where we're actually going to play the attack animation. We'll do that by setting the attack name to attack with a space plus the string of current combo. So the final string will look like this. It'll look like attack 1, attack 2, and attack 3. And as you recall, our animations are named literally that, attack 1, 2, and 3. So make sure that these are all the same in that sense. All right. And from there, all we need to do is say attack timer equal combo duration. We're going to say the combo window is open, and then we're attack lunging. This is the velocity we'll add in just a second. We're going to also add an else statement out after the if statement here, where we're going to finish the attack. This is basically if the max combo is on the 3rd attack, we need to finish. So let's go ahead and add the attack lunge first, because that one's just a little bit more straightforward. It's actually pretty simple. We basically want to get the forward of the player. So just to kind of explain this one more time, on our player, let me drag this down, you'll see that our player is on the Z index on the top right. You'll see the Z is kind of facing forward. Now this is also Z, but if you hover it, you'll notice it says a negative Z, or Z for any Americans or Canadians, ZZ. And you'll see that our player is facing forward. And that is why back inside of our script, we get the forward, like we're getting the plus of the basis, right? We're not getting the negative. The forward of the Y, we're going to set it to 0. And the X is going to be whatever this is. So we'll just set the velocity X and Z to the forward of X and Z here. And we're going to normalize it as well. And that's it. You can combine this into one line, by the way, if you'd like, but I just split it up so it's simple to understand. Oh, and I forgot, we also need to get the impulse You could also just do this if you'd like, but I keep it like this just so it's easy to see. Okay, lastly, the finish attack. This is the function that essentially gets us out of the attack state. It's going to help us decide, hey, are we going to go back into the combo attack? Are we going to go back to idle state, etc.? So the first thing we're going to do is create the function. We're going to create a variable. Should we reset or not? Should reset. That's what I wrote. We're going to say if, or not if, but we're going to say not combo window open. So if this is true, this means false, right? So if it's false, or if the current combo is bigger than or equal to the max combo. All right. Now this should trigger here, right? So right here, and this will trigger a finished attack, but we need this as a variable. So we need it to be a true or false variable. And in this case, if it is should reset, then we'll say state machine reset combo. The next thing we're going to do is create a function inside of it really quickly, where we're going to just return the input action of the if it's not equal to the combo action. And then lastly is to actually exit the attack state if we need to. But we need to decide which ones are we going to. And we've done this before in, I believe, one of the run one, or no, the land. Yeah, the land one. So it's the exact same thing. So you can just copy paste that if you'd like. But yeah, we're basically just checking to see if the length is bigger than 0. If it is, we'll go to run or walk. If not, we'll go to trend to idle. All right, let's go ahead and scroll up a little bit. Right under the update or physics update in this function, we're going to actually add code that allows us to make sure our player is going to 0. This is actually kind of important because we pretty much want to reset our velocity to 0 every time we attack, because otherwise the impulse attack, when we attack lunge, this will stack, right? Because if we keep attacking forward, it'll stack every time I attack, and we don't want that to happen. We want it to attack, reset to 0, attack, reset to 0, etc. All right, so it's time to go ahead and test our code and see if this works. And you can see I'm spamming it, but it's not really working. So let's go ahead and see why. The reason is right here. This one line, there is another reason, but the basic idea is we're not queuing the next attack. So this is one fix. We need to check if the window, if it's not open. Also, inside of the state machine, in our input buffer right here, this is pretty low. So let's go ahead and try increasing it, saving, and there we go. So basically our input buffer time was too short. So I basically couldn't click fast enough. That was the issue. And now you can see, and now you see that it works, right? But we do have another bug, and that is we're rotating through each combo very quickly. The second time I try comboing, also do keep in mind the buffer time. You can kind of play around with this. I tried 0.4 and that seems to work fine. So I'm going to leave it at that. But going back inside of our attack state, we clearly have something else that's not working here. And I'm going to go ahead and think through this logically with you. So the first combo that I attack with when I start the game is working, but the second time I do it, it's not. So that means that the second time I'm entering this state, it's not working properly. So that means something is happening in the ready and enter. Like we're missing something in one of these functions. We're not resetting something properly, basically. And if we think about it, it's actually kind of obvious through the animations. When we look at the animations themselves, it was skipping basically to right away to the third combo. So the problem is pretty evident that we're not resetting the current combo counter. So right here, actually we can do it right before the super enter. We'll do current combo equal to 1, and that allows us to reset it. We can also reset the attack name just in case, or the attack animation name to attack 1, and this should help. So now let's go ahead and test it, and you'll see that it's working fine for both attacks. Awesome. We are now doing a full attack. This is so cool, guys. I don't know about you, but I think this is awesome. All right, now there's one other thing that we kind of forgot to add, and that is to deduce or lower the stamina of our player. So down in our, actually, I want you to think, where do you think we should reduce our player's stamina? Hopefully you thought about it before I actually got to it. But right here in the execute combo transition, inside of this if statement, we can kind of add it wherever, but I think I'll just add it right here, player stamina here, and that's good. So now we can reduce our player stamina by the stamina minus the cost, and making sure that it stays above 0. And that's it. It'll work the exact same, but once I run out of stamina, I can actually run around a little bit. But once I am no longer able to run, I should no longer be able to attack. Of course, we can attack because we never check for stamina. So that is probably something we'll want to add. But I think we'll move on for now and go ahead and go. The dodge roll is the heart of Souls-like's defense. The secret is iframes. Iframe invincibility frames. Kind of a mouthful, but that's the idea. For a slice in the middle of the roll, you literally cannot be hit. So a well-timed dodge passes you straight through an attack. Now watch the window in the graphic. Roll too early or too late, and you still eat the hit. Timing is everything. Go into the next part. All right, so for our next step, we're gonna go ahead and take a look at the roll state, or dodge state in our case, because this is the dodge animation, you can see. So let's go ahead and duplicate the idle state, or just create it if you want. Doesn't really matter. Let's go ahead and open up the roll script. The first thing I'm gonna do is replace these variables with these. We're going to have a roll speed, roll duration, stamina cost, iframe start, iframe end, roll timer, and roll direction. These two are basically the animation like start and end, and you'll notice that the animation itself is about 0.4, and that's kind of why these numbers are there. So the stamina cost is pretty obvious. This is the length of the duration of the animation, or realistically how long you want the duration of the roll to be. The roll speed is actually going to be pretty high. You'll notice it's a lot higher than like the run state, and that's because the roll should be one big push forward. It's not going to just be a walk, right? So let's go ahead and just change the can move to false, and we'll also change the animation to dodge, and we can go ahead and delete some of this code here. We'll leave the gravity, but inside of the enter is where we'll first reduce the stamina by the stamina cost. We'll get our roll timer equal to the roll duration. And then more importantly, we'll get the roll direction. We do this pretty easily by getting the input controller and getting the movement direction, right? We wrote this in a couple of parts ago. So this is a very good helper function that will help us here. This is just to help us make sure that if this is 0, if we're not really getting any input, for example, then we'll have the basic direction in front of the player. So this is actually kind of important because sometimes you as the player might press dodge, but there's no input, right? You're not pressing ASW. In some games, in some Souls-likes, they might actually dodge backwards, right? I think in Elden Ring, that's what they do. So if you're not pressing forward or backwards or right, left, the player will actually do a dodge backwards, which it's not even a roll. It's an actual dodge. So in this case, you would do negative basis. But in this case, it doesn't really matter. We only have one direction we're going to roll. We're not going to overcomplicate this dodge roll, but a recommendation to you guys, or a kind of a continuation of this course, is to pretty much do this same thing, but have all 4 directions. So most Souls-likes will have dodge forward, backwards, right, left, and this animation pack, I believe, has all 4 directions. So if you'd like to try setting it up, I do very much encourage it. And then of course, we'll just get the roll direction.y equal to 0, normalize it, and then we'll tell that the player is .invincible is false. Then inside of the physics update, we're going to go ahead and update the roll timer. We're going to update t, which is just roll duration minus the roll timer, and this is basically going to set our invincible frame equal to whatever the dodge itself is. So if we are within the frame start, but we're not less than the frame end, so in this case 0.45, then we're going to be invincible. So this is going to be a true or false. And possibly the most important part is the velocity itself. Now this is a very basic calculation. We're just getting the roll direction.x times the roll speed. And then the last part is to go back into the transition, into the idle state. Very easy. If we say the roll timer is less than or equal to 0, we'll set the invincible to false, and then we'll transition to idle. And that's it. No, of course, that's not it, because we need to go into our input controller and add something that will help us roll. We're going to add it right before or after the handle attack, just kind of in the handle stuff, right? So we're going to handle the roll now. So all we need to do is duplicate this. We'll rename this to roll. However, this time we're going to also add the attack in here, because we should be able to roll or dodge even if we're in the attack state. Now we don't need this part, so we can just go ahead and delete that. We just need to check if the Q input exists. If it does, we'll roll with a priority of 3. 3 is going to be the highest priority in most of our code. If you don't want it to be 3, right, of course, I really do encourage you guys to play around with this. Also, I just realized this should be 2, not 1. We want our attack to be priority of 2, although it doesn't matter too much. It's just which of these are we kind of prioritizing inside of the queue. So again, do play around with these. It is kind of your choice. It's your game. And then we'll scroll down a little bit to this part right here. We'll duplicate this right here. Say if we're in the roll, then we also want to check for attack. And if so, we'll transition to roll. And now the last part, which is probably the most important, is to actually have the input. So we need to actually check for the roll by just saying handle roll. We say handle roll. And obviously here we need to replace this with roll, and that should be good. So let's go ahead and save, close this, and make sure we add our roll state. That is not the roll state, probably because I didn't rename the state name. I did not. Let's go ahead and rename this class name there. Hopefully you caught my mistake there. And now we can add the roll state. Let's go ahead and press play. Okay, we did it. That was a very big boost. It looks big mainly because our world is pretty small right now. So let's actually just go ahead and increase that. I'm going to do that by just increasing the size of this. And then I'm going to delete the static floor and just create collision shape again. We're going to do static body. We're going to do single convex, and that should be good. It'll create exactly what we want. And now let's play again. And there we go. However, it seems like our roll direction is in the wrong way. Like if I'm pressing forward and I roll, I'm going backwards, which honestly could be something that you might want. But in this case, we're just going to reverse the polarity of this by going over here and just saying negative, and that will switch everything that we want. And that should work exactly the same. Well, exactly the same, but in the right direction. All right, there we go. Now, to be honest, the roll speed is pretty high, so we could probably decrease this by a little bit. Maybe to 15. That might be a little better. Yeah, there we go. I think 15 is a really good number there. And yeah, there we go. Two things people constantly mix up. The hitbox deals damage and the hurtbox receives it. But here's the key. We're building them as one reusable pair. The exact script will power the skeleton enemies in the next series. So we can build it once, wire it carefully, and we can reuse it for everything that is going to be hit and is hitting something. That is our dodge state. All right. Now that we have pretty much finished most of our player, there's just a couple things left that we need to add. And a couple of them, are a little obvious. For example, we added the attack, but there's no way for a monster to know that it got attacked. And we can fix that by going to a weapon hand, or we could actually select this, and we add an area 3D. From here, we can add a collision shape. And what I'm actually going to do before I continue is I'm going to duplicate the area 3D and drag this to the player itself, and we'll get back to that later. For the collision shape, we can now select a capsule, and it is incredibly big. So we're going to go ahead and just make that smaller. Once you've decreased its size, let's go ahead and reset its position so it goes back to the player. If you don't feel like doing this manually, you can just skip ahead a little bit until I have the right size here and copy it into the shape itself. Okay, I actually did make a small mistake. I realized the reason it's so big is because it was a child of the axe, which is scaled up to 100. So I'm going to actually move it outside of the axe hand, and I'm going to reset the stats here. I'm actually just going to remake this completely. And we're going to go to the area 3D and reset the transform, the position, and just everything here. There we go. Now it's normal size. This makes much more sense. Now I'm going to go ahead and just move the area until it kind of looks like it's in position with our axe. And if you're wondering how we change the rotation of these things, if you press T, this will allow us to change it so that it's on its own axis. And we're just going to go ahead and make sure that it's kind of the size of the axe, not too big, not too small. And that looks good. Now you can go ahead and add more area to the axe itself if you'd like, but just for now, I'm going to leave it like this. Especially because in the future, if we add a sword, we want this area 3D to be the same. All right, now let's go ahead and rename the area 3D to Hurtbox. And then this area 3D will be Hitbox. We're going to go ahead and reset all the transforms for this as well. We're going to go to the collision shape and set a capsule shape. Now this one's a little easier. All we need to do is, oops, I'm going to just move it up here. Yep, make it the same size as our player. And this is the detection box of us getting hurt. Now this one is going to be a little harder to test, as you can imagine, because we don't have a monster yet to attack us. Both will actually be pretty hard to test because we don't have a monster, but we will get to testing eventually once we add something. Let's go ahead and start with the hitbox by adding a script. Let's actually add it manually here. We'll go to the player script. We'll add hitbox. We'll duplicate that and say hurtbox. We'll go to hitbox and drag that in. You can either drag on top of the node itself, or if you select the hurt box and scroll down on the side in the editor, you can go to the hurt box and drag it to the script. I usually will just drag it on top of the node, but you can use either way. Let's go inside of the hurt box and start editing it. The first thing we need to fix is the extend node is wrong. We need to extend 3D. And what we'll do here is create a class name as well. And then what we'll do is add some variables. We'll add the damage, the knockback, and the hit type. This is going to be especially important for later because we're adding, or as you remember, we added two different hits, right? We got hit big and hit small. So depending on what this is, we'll get hit big or get hit small. We're also going to want the variable owner node. And with this, maybe it's become kind of evident that this script is not only going to be for the player. This is going to be a reusable script for anything with a hitbox or hurtbox. We're going to make sure that we set enabled with true or false. B is just going to be true or false. So monitoring and monitorable will be true or false depending on what we set in here. On ready, we're going to set enable to false. And then we can connect the signal area entered. And this is a good way of connecting node signals. There is another way, which I used to do pretty often, which is by going into, let's say we're in the hitbox and we connect one of the area entered. We could connect it by double clicking and connecting this way. But I found that doing signals through code tends to be a little bit better practice, basically. There isn't much of a difference. It's just you reusing this code would have to reconnect the signal later. So it's a little confusing and just doesn't work all the time. So let's connect it by creating the function name. And basically the way this works is we'll say area entered. So this is kind of the trigger for the signal. And then we're going to connect it to this function. And if you guys want a more deep dive on signals and stuff like that, I have some videos on that on my channel, so go check it out if you'd like. But that's the basic idea. We're just going to have the function name here, and we've created the function. And now we just want to say if not monitoring or area is equal to self, we'll return. This is incredibly important so that we're not hitting ourselves. And then if area is a hurt box, so if we are hitting an area, right, we now want to say, okay, we're going to create a hit kind of dictionary with damage, knockback, type, source, and this is just all the variables. We're loading it into this variable here, and then we're going to say area as hurtbox apply hit. And now this function, we're obviously going to have a problem because we don't have this. And hurtbox also doesn't exist. This is supposed to be a class name. There's a reason why you might be a little confused on what this is, but it's going to be the exact same thing here. Let's actually go ahead and start that by going into our hurtbox. Here we go, and popping this out, and we'll say hurtbox. So now inside of our hitbox, you'll see the error goes away. And this is basically saying, hey, if the area is a hurtbox from this class, then we'll do something. And what are we going to do? Well, it's actually a little easier than the other one. All we're going to do is export the max health and the regular health. We're going to actually create two signals, hit received and died. These are going to be used later, but we're going to make them now because it's pretty simple. And before we continue, we need to make sure we connect our health to our max health. And the last part is to just make the apply hit function because we are calling it in here, but it doesn't exist inside the hurt box. So we need to make sure we make it. All we need to do is say apply hit dictionary, because as you recall, we made a dictionary here and we're passing it through the function. We're going to get the owner node. And if the owner node exists, or if the owner node is invincible, then we'll just return. We don't want to apply the hit to an owner that is invincible or ourselves. Or sorry, not or, but like and. So if the owner node is invincible, then we don't apply the damage. Then we'll hit received.emit hit, and this is emitting the signal hit. So we're going to get back to this again later, but just know that this is our way of sending out the signal to whoever this is connected to. Then we'll get the damage by getting inside of hit. We're going to get the damage name, and then we're also going to turn it into an integer. This is just a confirmation that it is an integer. We don't want it to be anything else. And the last part, arguably the most important part, is if our health reaches 0, then we should die. We'll emit die. All right, and that is it for our hurt and hit box. Now our hit and hurt box are connected. There is no good way of testing this at the moment. What you could do is create a dummy. So inside the world is create a dummy, something that doesn't move that has a hurt box, and you can see if you can hit it. But I'm not going to do that in this part. We're going to go ahead and continue with the hit states. We are going to get testing to this eventually, since we're going to be creating our own monster in one of the later sections. But for now, when you get hit, two things sell the impact. We knock you back away from whatever you hit you, and we stun you for a beat, so you can't just walk through it. Small hits gain a small knockback, while big hits get roughly double that. That readable reaction is what makes combat feel like it has weight to it, instead of just damage that has a number ticking over you. Let's go ahead and move on to the next part. We want to go ahead and duplicate one of the states here. We're going to duplicate the run state, and we're going to have hit small state. This hit small state, we're going to go ahead and hop into it and rename. The first thing we want to do is rename this, which I always forget to do. And we're going to add some new variables. We're going to have a stun duration, knockback speed, timer, and knockback direction. So this is pretty obvious, right? If we get hit, we want to get knocked back in the opposite direction that we're getting hit. The stun duration is going to be how long are we stunned for, right? We don't want to be able to move when we're getting hit. That wouldn't make much sense. And the knockback speed is, again, how much I'm getting knocked back. And then the timer, I think that's a little bit obvious. It's kind of the timer for the state itself. We're going to change the animation to hit small, or whatever you hit, or whatever you renamed your animation to. If you remember, inside of our player, we added inside the animation tree, hit big, hit small. Make sure you just rename this animation to whatever that is. Right after the enter, we're going to go ahead and set the timer equal to the stun duration. And now this is going to connect us to the hit itself. So we're going to say hit direct dictionary. We're going to create an empty dictionary, and we're going to say state machine.get last hit not equal null, then hit is equal to the last hit, which we will get to in a bit. But let's get rid of some of these errors because we actually won't need this. Let's go ahead and delete these. I'm actually going to go ahead and just delete most of this code inside the physics update, since we won't need it. Inside of the enter, this is where we'll create the actual knockback. We'll do this by getting the source first. So we need the source of what hit us. And we'll do this by saying hit.getSource. So if you remember, inside of our hit box, we create hit with source, and that is the owner. And owners of a node have a global position. So basically, we're just going to get the direction by subtracting our position to the source of that position. So whatever is hitting us, we're going to basically get knocked back from that source. But that only gives us the direction. Just keep that in mind. And then we're going to set the y equal to 0 and have the knockback direction be normalized. We're going to go ahead and get the timer minus equal delta. And then the last part is to actually create the knockback itself, which is a little simple. I want you to go ahead and pause the video here and try it yourself. This is relatively simple code. It's going to be the exact same thing as the roll state. So if you remember here, we're basically just multiplying the velocity, roll direction times the roll speed. We're going to do the same thing here, but hopefully pause the video and you understand that we're going to be using the knockback speed and knockback direction instead. The last thing we need to do is to make sure we transition out of this state back into the idle state by saying, hey, if the timer is less than 0 or equal to 0, then we'll transition to idle. That way, once we've finished getting hit, or our kind of hit state is finished, then we transition back to idle. Now we're going to go ahead and close this and duplicate it once more. We're going to do hit big. And this one is pretty simple because all we need to do is change some of the variables. This is going to be 8.0. I'm going to basically almost double everything. So this way, everything feels like it just hit us way bigger. We're going to do hit big, and that's it. Everything else remains the same. We've already wrote all the logic. All we need to do is increase the variables here and save it. And now we just want to add this to our states. Let's go inside of our state machine and go ahead and add hit state and then hit state again. But we forgot to rename the hit state small, so we're gonna go ahead and do that. Hit big state, then add that once more. I'm gonna rename these to hit small and hit big like this, and there we go. We also can rename the roll state like that, just to make sure it's all consistent. Go ahead and save, and that's it. Now again, it is kind of tricky to test this because we're gonna be transitioning to this state when we get hit, which is a little tricky to do that here. But we'll get to that once we actually add a monster. Now that we have most of our states, we just have one more big state, which is the death state. This is arguably one of the more important ones because this will, have us die and reset the game. Let's go ahead and rename it to death state. We'll replace some of these variables with animation override, death duration, respawn delay, timer, and death complete. This is going to be the respawn. It's just like how long do we delay before we respawn. This is the length of our duration of death, which is the animation length, basically. and the name of the animation. In this case, we can either put this like so, or we can just rename this to death right under the enter. I'm going to delete all the old stuff and replace it with timer equal death duration plus respawn delay, and say death complete equals to false because we haven't died yet, so we've just entered this state. So we want to make sure that we set this to false. We'll make sure we stop all the player movement by saying velocity equal to vector3 0. One of the more important parts is to disable our input, because we don't want to be able to move or do anything if we're dying. Now, one part we're actually going to edit here is normally we have the move and slide outside of this statement, but in this case, we're actually going to keep it inside. And that is to keep the player on the floor. Inside of this if timer, we're going to replace it with if timer and not death complete. Then we'll say death complete equal true and respawn. Our respawn function is going to basically be resetting some things. So first, we're going to get our hurt box and reset the health, which we'll have to add in just a second here. We'll also get the respawn position, which we also will need to add, but basically we'll just set our player position to the respawn position. We'll say if controller, then enable input. We'll also transition to idle to make sure we reset the player's state to idle. And that's it. That's all for our death state. It's relatively simple. We just basically need to make sure we disable most things, make sure we're on the floor. We reset our player and respawn to wherever our respawn position is. Now, inside of our hurt box, we need to make sure that we add that script that or function that we just added. Let's go ahead and find the hurt box and just go down here and add reset health, where we just say health is equal to max health. And going back to our death state, we'll go ahead and say get the respawn position. We'll go to our player. I don't think I have open at all. We'll go ahead and open this here. And all we need to do here is we'll say respawn vector position 3. We'll get our respawn position, and we can either set, and that's it. A complete 3D Souls-like player controller built from scratch. Movement, a third-person camera, centralized input, attacks and combos, a dodge roll with iframes, hit reactions, and a death and respawn system, all in one clean state machine. That's genuinely a very solid foundation that you can ship on a full game. Now, in the next series, we're going to give him something to fight, an enemy AI. If this got you here, subscribe and go take a break because you earned it. Position ourselves, or we can just say self.global position. This way, we'll have our start position wherever the respawn is as well. All right, and that's it. That pretty much completes our entire player. Congratulations, you have finally finished your Souls-like player with most things connected. The only thing that we haven't really tested is the hit small, hit big, and death, which we will get to once we add a monster. I just realized we need to make sure we add the death state before we end this part. So let's go ahead and do that. Hopefully you caught that I didn't do that again. And there we go. But that is it. That is all our state machine done. Our player is done. It has a hitbox, hurt box. Our hurt box and hitbox are going to be reusable for when we create the monster. So without further ado, I will see you guys in the next part. But congratulations. Now is a very good time to take a break, get some air, stand up, stretch, do whatever you'd like. But I will see you guys in the next part.